Welcome to the Esri Canada virtual seminar on modernizing the transportation system. My name is Authoritative, and I am extremely excited to be sharing this next few hours with you. So first of all, on behalf of all of the presenters that you're about to see today, I wish to thank you for taking the next few hours of your day and joining us today for this seminar. So before we dig in, I'm going to go through some housekeeping information that's going to be important for us as we move forward. Okay, the sessions that you're about to see are going to be recorded. In fact, they are being recorded. So for those of us who can't join, you'll be able to peruse them at your convenience a little bit later if you wish. Your camera and your microphone has been disabled. Okay, so you can't quite participate in that fashion. However, you can participate in today's event. There is a chat function within your window, and I encourage you to use that chat function if you wish to participate in terms of communicating with the other participants. Everyone can see your chat, so feel free to participate there. However, if you wish to ask questions of the panelists or any of the speakers, please use the Q&A box in your window. Through that, you'll be able to ask questions. Now, we may not be able to answer the questions right away, but that's okay. We do have a few sessions set aside for responding to your questions. We do have a live, we're calling it a break at about 2:15 Eastern time. But this break is actually going to be a live chat where I'm going to be hosting an opportunity where all the speakers are going to come together and we're going to respond to those questions. So please, between now and then, go right ahead and insert your questions into the Q&A box. We'll have an opportunity to go through that. So we're calling it a break, but it's actually a live chat. We'll also have another opportunity to get to those questions near the end of the day at 3:25 Eastern time, when all the speakers are going to come back and we're going to be able to dive into this live chat again. So it's going to be an exciting time. And after we're done this presentation or after we're done the seminar, please make sure to respond to the post-event survey. I think there's a little prize in it for you, if I'm not mistaken. So you'll be interested in that. But without further ado, let's dive in. So a little bit about your host, me. My name is Arif Rafiq. I'm the Transportation Industry Manager with Esri Canada, based out of Toronto. And essentially what that means is I lead the organization when it comes to any of our endeavors within the transportation space. I've been with the organization almost 6 years now, so I am not a GIS native, as they say. I don't come from the GIS realm. I actually come from the transportation realm. I spent most of my time, most of my career pre-Esri, designing and implementing data management systems for highways in the United States Department of Transportations, and also did a lot of advocacy work in East Asia, helping them with their road asset management systems and other data management systems. So quite a bit of experience in that realm. These days, of course, I'm here to serve Canadian municipalities and other government agencies. And so why don't we dive right in to the very first presentation, which I'll be hosting. All right. So I told you I started working at Esri just less than 6 years ago. One of the first things that I did was, of course, I was telling my family about what I was doing. And I had this chat. Now I'm going to share this chat with you. I had this chat with my mother-in-law. And I was trying to tell my mother-in-law what I did. She asked me, what do you do for a living? So I explained to her. I said, Mom, what I do for a living is I apply GIS technologies to find practical solutions in the transportation space. And she looked at me and says, I don't understand what that is. So I said, okay, let me see if I can describe some of these practical areas where we're trying to solve some challenges using GIS. Some of those areas included, so I talked to her about curbside management. I said, as we're moving into the future, we have lots more people like food delivery and goods delivery happening at the curbside. So we need a better way to manage our urban curbsides. I also talked to an area that I work in as being able to more efficiently do goods delivery, because as we all know, we're all ordering more and more things, and our expectations of those delivered goods are in less and less time, and we got to get better at that. So this is a practical area that I work in. I also work in sustainable construction and maintenance, right? We constantly have to build, we constantly have to maintain this infrastructure that we're all using for transportation, and it needs constant update, and we want to do it in a sustainable way, which leads us to infrastructure investment and health. We're always trying to do better at making sure that our infrastructure is in good, usable condition. Electrification and automation, right? You look at our transit systems, our vehicles, they're being more and more electrified and soon to be autonomous in the near future at some point. active transportation. We're trying to move a bit more, get out of our single occupancy vehicles so we can actually start moving about, walking, cycling, using transit, right? Which brings us, of course, to equitable transit. Public transit needs to be accessible to everybody. And of course, one of the ultimate functions in order to help make that happen is, of course, policy reform. So this is what I told my mother-in-law. I said, these are the areas, the practical areas that I work in to try to improve the realm of transportation. And she says to me, she goes, that's kind of complex. And I said, okay, let me break it down for you a little bit more. Let me see if I can summarize these things into some, bigger bullets. I said, many of us, we live in cities. And, I would argue that most of us don't like the idea of living on top of one another. So we got to be smarter when it comes to building our urban centers so that we can all have a livable place and are happier in these environments. So smarter urban density is one of the things that we're trying to achieve. The pandemic that we're in right now is a great example of things that could happen in the industry and the world, and we got to be able to be agile so we can respond to those things much more effectively in terms of our strategy and operations, right? There is such a wide gamut of participants in the transportation industry. There's thousands of people and companies who are contributing to this. So how can all of us be more collaborative and get along? Well, it comes down to having some sort of authoritative system of record. How do we know what data is real? What data is authoritative? How do we know what data we can trust? So defining this authoritative system of record is important to us. Integrating public transit, the GTA, and in fact, we have a speaker today, the Greater Toronto Area is a great example of how transit systems have invisible borders, between different areas. And so in order to integrate public transit so people don't have to think about the different jurisdictional boundaries of where they're going, this is kind of important to us. And so we're trying to do that here. And of course, we lead it down to this idea of urban mobility, or be able to move people and goods around in your city. And Mom, let me make this a little bit more simpler, actually, because I think even that can be a little bit complex. If I can bring these things down to 3 words, right? Those words that I would choose would be resilience, collaboration, and access. The example I would use for resilience is, of course, we talked about it already, this idea that we're in this pandemic. How can we be resilient to changes in the industry, sudden shifts in the way that we interact with people, sudden shifts in the way that we provide our services and goods? How can we be resilient to those sort of things? These are one of the things that we're trying to do. On collaboration, right? Bringing all of these thousands of participants together so that we can all work together. Because if you think about it, we have so many people contributing to the transportation space, but in the end, this is a shared system. It's a shared system that you and I use on a daily basis. And so because it's a shared system, we've got to work together. And of course, access. Transportation needs to be accessible to everybody, right? Regardless of where they are, where they come from, they need to have access to transportation. So to boil it down even a bit more, if I were to bring this down to one phrase, I would call it freedom of mobility. And what that means is transportation shouldn't have to be something that I need to think about. I shouldn't have to try to figure out what my fare is going to be among the 6 different transit systems that I have to use. I shouldn't have to figure out whether it's going to be safe for me to get somewhere. I shouldn't have to figure out whether or not the road is going to be impassable for me. Like, all of these things should be transparent, because all I want to do is get to my destination. And so I think if we can make transportation transparent, then we've achieved freedom of mobility. And so my mother-in-law looked at me and she said, okay, I understand. And then she was quiet for some time. And then she said, if this is what you do for a job, she goes, you're not terribly good at it, are you? That took me back a bit. I said, what do you mean I'm not good at my job? And she goes, I feel like it's gotten worse. And she reminded me decades ago, when she was younger, she would be able to go down to the bus stop, take a look at a schedule, a printed schedule, and understand that schedule so that she would know with confidence that she'd be able to get to wherever she was going, because the bus would arrive at a certain time. She'd get onto that bus. The bus driver would say hello. She'd find a seat. She'd be able to get onto that seat and wait for her opportunity to get off the bus. And she'd get off the bus. And with a certain certainty of safety, she'd be able to proceed with her journey. Right? And she's like, now, she's like, I don't even understand. Sometimes I go to the bus stop and there is no schedule. I'm like, I don't know if I have the right app on my smartphone anymore to be able to use the bus. And I know that there's more options. I know that I can call a ride if I need to, but I'm not sure if this ride service is something that I can trust. I don't know how to use it. I don't know if I'm going to be able to use the app correctly. I'm so confused. There's so many options out there, and it is so much more complex. And that hit me like a ton of bricks. I was like, I often think about these things like, with all this new technology that we are being exposed to in the transportation realm, with all these new options, I had this perception that it's better to have more technology, to have more options. We have more ability to move around. This is good for us. But clearly, my perception was not being shared by others. And so I asked, why do we need to modernize transportation? Because if we're really going to achieve freedom of mobility, well, that freedom of mobility needs to apply to all Canadians, regardless to their age, their background, where they come from, their income classification, any of that. It needs to apply to everybody. And it's got to make a lot of sense. So why do we need to modernize transportation? Well, we've got a lot of work to do, but I'm excited to do it. And today, for today's seminar, we have a number of speakers here who are going to share with you their individual perceptions of modernizing transportations. We're going to be talking about a lot of different areas in transportation and how we can all work together to be able to modernize these areas. Later on, near the end of this seminar, I encourage you to sit through it. There's going to be a lot of nuggets for you to share. But by the end of this seminar, I'm going to return and I'm going to be talking about a few of the, maybe some of the more practical things that we can do if we're ever going to get closer to this idea of freedom of mobility. Because I think this is profoundly important to me. I think it's profoundly important to the speakers that are going to be sharing their insights today, and it's probably important to everyone here on this call. So once again, I thank you for your time to join us today for this seminar, and I'm eager to looking forward to seeing and what our speakers are going to be sharing with us as we get into modernizing our transportation systems. So I'd like to bring our first couple of speakers to, I was going to say to the stage, but this is not really a stage, it's to the virtual stage. I'd like to invite, actually, here we go, here is her name. So I'd like to invite Lindsay Bedard, who is a GIS consultant in the Urban Solutions team, and also David Kosowski, who is a GIS and urban design specialist, both from Esri Canada. And they're going to be talking about unifying planning with urban design systems. So Lindsay, David, if you can please turn on your cameras, turn on your microphones, and go right ahead and share this and share your screen. Come join us.
All right, thanks everyone. I'm Lindsay Bedard, and I'll be presenting with David Kosowski. Today we will be discussing ArcGIS Urban as a potential communication tool to support collaboration between engineers, designers, and planners. A bit of a presentation overview. We'll provide a brief introduction, then we'll touch on smart cities, then we'll jump right into ArcGIS Urban, what it is and what it can do, planning scenarios, and then we're really going to focus on custom metrics. Then we'll discuss ArcGIS City Engine, how it can be used and how it pairs with ArcGIS Urban. And then we're going to wrap up with some open-ended questions and final remarks that will hopefully spark some ideas for you to take away from this presentation. Small cities are the most common city typology in Canada, and they are home to millions across the country. For purposes of this presentation, we'll assume a small city is less than 150,000 people, but that definition may vary regionally or on a case-by-case basis. Although in recent decades, small cities were declining, there are now many that are facing unprecedented and even unexpected growth. Planning for these accelerated rates of growth and development is paramount. There's a need to consider job creation, residential development, transportation infrastructure, and often servicing upgrades, which can include electrical utilities, water and sanitary services, and telecommunications. Smart cities harness technology to foster sustainable, resilient, and livable cities. And it's important to note that they don't actually have to be cities. As we're seeing, there can be smart towns or regions. So if your community isn't technically a city, please don't feel excluded by this general term. Smart cities, though, do require smart planning. This planning process may involve multiple options and stakeholders representative of various interest groups and specialties. Discussion during the planning process can help with cost efficiency, both in terms of implementation and long-term maintenance. There's no one-size-fits-all approach, so a city can integrate some principles or some elements of technology to support equitable, safe, and enjoyable cities. So we are now going to discuss some of the features of ArcGIS Urban that can help cities, regions, and municipalities visualize current and future conditions. With ArcGIS Urban, you can visualize scenario planning for parcels or neighborhoods and review custom metrics. This will be the key focus of our presentation today, but as you will see, other features will make their way in here as well. You can compare and evaluate current zoning and proposed variances and developments with surrounding context. This is an exciting feature because so often you review site proposals without knowing what is happening in the surrounding area. You can enhance the decision-making process through efficient review of scenarios, plans, and development applications in a 3D environment. And you can gather feedback for proposed and ongoing development projects. And you can do this within Urban and through integration with other ArcGIS solutions. For scenario development, we looked at a hypothetical future development site in the city of Moncton. This is a city in Atlantic Canada with approximately 85,000 people currently. This is a greenfield area within the city limits with residential, open space, and commercial zoning. It's important to mention that although we use data from New Brunswick and the city of Moncton for this presentation, the work shown here was developed for theoretical and training purposes, so the data may have been adjusted or altered in some way. Therefore, these scenarios are not necessarily reflective of the city's planning goals or objectives, or even policies currently in place. We then created potential 3D scenarios for a suburban character neighborhood with moderate density, which included low-rise residential, commercial retail, and mixed-use development. Then we configured custom metrics and referenced the custom metrics dashboard to facilitate review and discussion. So the custom metrics and the custom metrics dashboard is a really exciting feature in ArcGIS Urban. The custom metrics help us quantify the influence of potential land uses, and the dashboard updates automatically as you work. We configured custom metrics for number of households, population, number of jobs created, number of parking stalls required, number of daily trips, and different modes of transportation. Additional custom metrics that come preloaded in Urban that can be configured include energy use, CO2 emissions, and water use. Sources of data that you can use to configure the custom metrics are existing public data, such as census data or data compiled by Natural Resources Canada, data enrichment layers available through ArcGIS Online with the use of credits, and manually input data, including data from zoning bylaws. One of our main focuses today, I should say, will be on parking requirements for the number of households and space uses within the plan area scenarios. We focus a lot on parking because this is often a limiting factor for development due to the spatial requirements of surface parking and the cost associated with subsurface parking. The metrics were configured to reflect the city of Moncton using regional average dwelling sizes for specific housing types and applying regionally appropriate job metrics for space use types, and also using spatial parking requirements outlined in the bylaw to configure the number of parking spots created and required. The number of parking spots, or the number of required parking spots, I should say, is based upon the requirements for parking spaces per household type and space use type. For example, the number of required parking stalls for retail spaces is based upon gross floor area, so metrics reflected that. With the dashboard, we can review where parking requirements are highest. Another option would be to review where parking requirements or different parking requirements by space use type. The dashboard can be viewed for an entire scenario plan area, as shown in a previous slide, or for a specific parcel. This allows you to review overall targets or site-specific requirements as needed. So in this particular parcel, we currently have 20 parking spots on the site through surface parking, and there's 44 parking spots required. And then you can adjust space uses accordingly to help achieve targets. In this instance, we added subsurface parking to help provide more parking stalls to achieve the minimum requirements. The dashboard updates as you make changes to buildings and parking areas, so you can quickly verify whether targets have been met as you make modifications. We now have more parking stalls than required for the site, so we could explore options like shared parking or bicycle parking facilities. So now we'll discuss some scenarios. In this first scenario, which was also shown on a previous slide, we predominantly have surface parking with limited parking garage availability. Based on the population and the jobs created, which is going to stay the same through the next couple of scenarios as well, we currently have 938 parking spots provided, but we require over 1,400. In this next scenario, we added some parking garages subsurface. So we almost have enough parking spots now. We have just under 1,400. We therefore decided to explore the possibility of on-street parking to accommodate some of the parking requirements. So here we added another space use type and configured the metrics so they would reflect a 20-meter right-of-way and parking on both sides of the street. This gives us far more parking than required and maybe a worthwhile consideration for business patrons. So yeah, we're way over 1,500 now, and we only require 1,400 parking spots. So we could also configure a new space use type metric for on-street parking for one side of the street if we wanted to explore that. This alternate space use type would also allow for wider sidewalks, bike lanes on this street, or additional green space for stormwater management. Next, we can look at daily trips and modes of transportation. For this dashboard, we configured the number of daily trips to reflect the number of jobs and population in the scenario. For simplicity, we did not include the patrons for the various space use types in this configuration, but that would also be a metric you could define to help estimate the requirements for the transportation network for level of service. If we create a new scenario and add residential buildings in this corner up here, almost as if we were phasing development and construction, we can now review the updated number of daily trips and the modes of transportation and how they change with that change in population. So we're going to keep the jobs the same as we switch, but we're going to increase the population. And we'll go back and forth between these slides a little bit. So if we increase the population from 621 to 907 through residential development, I'm going to go back. And we'll look at walking as the mode of transportation. And that's really simplistic because what that really means is sidewalk and trail users. They don't necessarily have to be walking. But if we look at this mode of transportation, this mode of active transportation, we'll go from 216 daily trips to 260. So the needs of the sidewalk may change in response to that. So now I'm going to hand off the presentation to David to discuss ArcGIS City Engine and conclude our presentation.
Thanks, Lindsay. So ArcGIS City Engine is a parametric rule-based 3D modeling program that allows us to generate accurate data-driven representations of cities and surrounding areas. In City Engine, you can start with 2D GIS and CAD shapes and data and apply scripts, or in City Engine, we call them rules, to these 2D forms to generate 3D models with parametric attributes. The software is typically used to model urban environments, including buildings, roads, sidewalks, and parks. In City Engine, we can quickly build out realistic-looking cities, development proposals, complete street designs, and we can also perform analyses on street and pedestrian experiences, transit modeling, and shadow and view analyses. City Engine has been used to model historical areas such as medieval cities, and even imaginary and futuristic cities like you can see here. In this demonstration, you can see how quickly streets and sidewalks can be adjusted to test out new design ideas. Here, you can see I'm changing the on-street parking. I'm taking that out and putting it to none. And then I scroll down and change some more of the parameters. Here, I'm adding in a bus route. I'm changing the bike lane widths and changing the color of the bus route so that it's visually distinct. We can change the bike lane color as well. I can add in a center median, so I can change that from a line to a tree buffer or anything else that's in between. I can also put in street lamps or take them out. And I can change the level of detail so that the rendering and visualization becomes a little bit more accurate and nicer looking. We can also adjust how many vehicles, pedestrians, and bikes are on the road by changing the vehicles per kilometer and the percentage. Everything here that you can see is also being driven by data. So we get great reporting attributes and metrics that you can use in your decision-making that go beyond the visualization. So taking what we've got in urban and bringing it into City Engine, if we take Lindsay's demonstration there, we can bring that into City Engine and we can start to modify street center lines in more detail to visualize and gain insights at a finer level of resolution. Here, the drive lanes have been modified and visualized at 3.5 meters. We have a shared bus lane and bike lanes that are 3 meters wide. We also have wide sidewalks with a 2-meter wide planter and bench allocations. The metrics on the right are just a demonstration for this seminar today. But like City Engine, ArcGIS Urban has robust reporting and dashboard capabilities. We can visualize buildings with textures as well as different space use types. And we can use photorealistic renderings if we want, and even facade photos to inform what those buildings look like. And I've also created a second scenario here based off of Lindsay's work to showcase what another scenario would look like with different street allocations. So here we have 1.5 meter wide tree plantings, 3.5 meter wide drive lanes, a 1.5 meter bike lane, and a parking lane that's 2.75 meters wide. If we compare the two scenarios side by side, you can see that City Engine can be used to efficiently model out a large variety of transit options. The changes that you're seeing here can be made in a matter of seconds, as you saw in the demonstration video, and they can be published online for a variety of stakeholders to view and interact with the scenes. City Engine also has a lot more advanced visualization capabilities beyond what you see here. There's a virtual reality export feature that creates a fully immersive environment where a person can wear a virtual reality headset and experience street and building designs at a realistic scale and level of representation. So it's a truly immersive environment. City Engine also provides the capabilities to export to a variety of game engines, including Unity and Unreal Engine. This allows for even more enhanced visualizations, improved lighting and texturing, animated vehicle and pedestrian simulations, and fully interactive walkthroughs, just like you would find in some video games. So moving forward, we want to consider a few questions around the needs of Canadian cities. Are the personal cars the future, or do we expect an increase in electric vehicle car shares? How can cities adapt to the increasing demand and usage of electric vehicles and self-driving cars? Can we use real-time parking availability indicators to support shared parking initiatives? Can we integrate real-time transit arrival times at stops? Is there potential for roadway and sidewalk surfaces to resist snow buildup? And how can we effectively integrate smart lighting technology into our transportation networks? Finally, we just want to reiterate that smart, livable cities require collaboration. ArcGIS Urban can be utilized by a range of professionals to spark discussion and debate, and it really excels in this area. Visualizing zoning of plan areas can highlight opportunities, as well as different strengths and weaknesses of the scenarios that we're modeling out. ArcGIS Urban and City Engine can both facilitate the exploration of multiple scenarios, as you saw in both of our demonstrations. So with that, we thank you for listening to our presentation, and we'll pass things back on to Arif.
David, thank you very much. That last, the second last slide you shared with those questions, it got me excited. Actually reading those questions, I'm like, I want answers to those right now. They are fantastic. I love it. So thank you, David. Thank you, Lindsay, for sharing your insights today. I want to encourage the audience actually to ask questions. Just like I have some questions I'd love to be able to get Lindsay and David to be able to respond to. So I would encourage you to do so. In fact, in your Q&A box on your portal, some questions have already popped up. And I had something to do with that as well. So I snuck one of my questions in there as well. I encourage you, add your own questions, upvote the questions that you like. And when we get to the live chat, we're going to ask our presenters those questions. But we're not at the live chat yet. In fact, we have another speaker who's going to be coming up right now. And our next speaker is Dave Monahan. Yeah, I work with Dave quite regularly, actually. So he's a colleague of mine, the Internet of Things industry manager with Esri Canada. And he's going to be talking about real-time analytics for day-to-day operations and long-term strategic planning. And he also happens to be a ArcGIS velocity expert and an avid motorcyclist. Dave, you want to turn your camera on and let's get you to participate.
You had to throw the avid motorcyclist piece in there, right?
I did. Yes, I did.
Okay, well, thanks, Arif. That was an interesting introduction. Good afternoon, everyone. It's my pleasure to have this opportunity to talk to you for a short while this afternoon about how real-time analytics and IoT plays a role in modernizing the transportation system. So as Arif mentioned, my name is Dave Monahan, and I'm the industry manager of IoT for Esri Canada. And although I joined the company at the beginning of this year, my background is somewhat of around, I guess, 30 plus years in the geospatial industry, working with all levels of government, including the transportation industry. However, I don't consider myself to be as industry savvy in the transportation space as your audience here today, Arif. But nonetheless, bear with me. Let's see how perhaps the industry that I'm in can help yours. And so let's first talk about some takeaways. So this session here, for you guys, it's all about trying to help you understand and explain how Esri can help in this space here. And if I do a good job in this session, I'll try and at least have helped you understand a bit better why we think here at Esri we have what it takes in terms of technology, people, to help you more eagerly embrace modernization and seize the opportunity to do things in a new and perhaps different way. And so I'm going to talk about how our IoT real-time and big data platform, combined with you and our partners, can help empower your organization to become better at a couple of things like I've mentioned here. Things like understanding what's going on, being better at being predictive and prescriptive, and also being better at long-term strategic planning. Now, let's start with helping to become better at understanding what's going on. And to tackle that, it's good practice to start by understanding, I should say, the landscape as well as the challenges. Now, just a quick disclaimer here. My area of specialty is more IoT and geospatial and not so much transportation, as I mentioned before. And so the bullet points that I've got listed here are kind of sort of just a summary of things that I've gathered in conversations with people that are involved in the transportation industry. So It's by no means meant to be authoritative and exhaustive, but nonetheless, it kind of sort of feels like, you know, they're shared by most people in the industry of transportation. So let's start over on the left-hand side here, where I've listed a few things that probably strike a chord with you guys. Things that you're dealing with are things like, for example, increased real-time data sources, the fact that each one of these carries a location component, and being asked to, or having the need, I should say, for better data-driven decisions. Now, on the left-hand side, you get some familiar challenges, but one of the interesting ones is that last bullet that's mentioned there, where it's all about dealing with deploying corrective actions to incidents in a timely manner. And that's a good example of not only a challenge, but also a desired outcome. So maybe you're asking yourself, well, Dave, where are you going with this? And so let me put it to you this way. If I were standing on a stage in front of you guys and I were to start with a sentence that says data rich, and then I paused for a second to hear what you guys would respond with, in all likelihood, you'd respond with something like information poor. And that's an interesting phrase that's been around for quite some time. And it actually made its appearance in a best-selling book that's called In Search of Excellence. But what's really interesting about that is that actually was first stated in 1983. And so here we are, 38 years later in 2021. And for a lot of organizations, that phrase might still kind of sort of resonate for the organizations. And it's not because we haven't learned or gotten any better. I think, to some extent, it really has to do with maybe the fact that it's too much and too fast to be able to harness that, and let alone make sense of it all. And maybe this is a little bit of what our mother was talking about when he had his chat with her. It feels like sometimes we keep playing the catch-up game. And that's where I think here at Esri, I think we can help you guys with some of that. And so let me just try and make sure here that this video starts. Okay, so here's a real world example of where technology, partners, and people have come together to become better at understanding what's going on. And maybe this is a bit of a shameless plug into what we do on the IoT side, but that's okay, because that's what RF asked me to do this afternoon. And also because he played an instrumental role in making things happen in what I'm about to explain here. What I'm talking about is the Bell Esri partnership. And whereas this partnership is focused on smart city initiatives, its concept and approach is quite applicable for smart transportation. So what you're seeing here is a 3D view showing a whole bunch of different sensors in the transportation space. So you're seeing vehicles, you're seeing buses, all kinds of transit-related sensor information being shown up here. So it's a great example of tackling the too much, too fast, let alone trying to make sense of it all kind of challenge, right? And what you're seeing here is just a small and quick demonstration of our two technology platforms coming together to integrate many different sensor feeds into a single common operating picture. And so what is Bell doing in this partnership? Well, they're tackling the too much, too fast issue. And they're bringing together a myriad and wealth of different IoT sensor feeds from many different sensor companies into a single API that our technology can tap into. And so for the cities, it's really all about removing the burden of finding best of breed sensors and having to integrate all those together and deal with multiple vendors. And on the Esri side, what we bring to the table, we bring our IoT solution, which is Velocity. And Velocity in this case is connecting to Bell's IoT API to get the raw data. And then it makes use of ArcGIS Online tools to create the end user interface and experience where data is transformed into useful and actionable information. So the partnership provides an opportunity to do cross-analysis of different data sources to extract new information, never before thought of. And so that's a good example of industry-leading technology platforms and motivated people coming together to help become better with smart cities. And because that works well on the smart city side, it begs the question, why don't we just copycat that same kind of approach to become better with smart transportation? And that leads me to talk about a customer example where our IoT offering, Velocity, right, has helped this customer become more efficient. And I'm talking about here UPS, one of the world's largest express and package delivery companies that you guys know well enough about. And just to give you an idea of the size of this company and what they have to deal with sometimes, let's talk about the peak holiday season. And I'm using statistics from back in 2016, where they delivered 712 million packages globally. And that's, of course, before COVID. And the interesting fact here is that when they do individual deliveries to your doors, as opposed to business deliveries, one is up, which is the individual deliveries, and the other one is down on the business side. And so if you bring that into the context of COVID, you'll say, well, Dave, that's kind of sort of normal to arrive at that kind of a trend. But if you think about it from the financial aspect for UPS, individual deliveries cost more than business deliveries. And in fact, according to UPS, it's that last mile that you guys are well aware of. That last mile of delivery is the one that costs the most. So they obviously had to ask themselves a question: how do we become better? How do we solve this problem? How do we save some money? And so what they decided to do is to use Esri technology to analyze volumes of historical onboard sensor data, some delivery routes, and their GIS data. And as a result, they implemented a system that's called Orion. And that's powered by GIS technology and a whole bunch of advanced analytics that often, in this case here, in terms of result, often prescribes delivery routes that are counterintuitive, but that did in fact create measurable benefits. And I'll give you an example of that. They found out in sifting through all of this data and applying the analytics that left-hand turns, if they can avoid that, it actually eliminates the need to cross traffic, and therefore that saves some time and increases the driver's safety. And so this is a good example of GIS technology helping the company operationalize the whole no left turn policy. And so if you're wondering what kind of benefits they got from that, what they had to say is that saving just 1 mile per driver per day over 1 year can save the company up to $50 million. I mean, that's huge, right? But that's not all. They didn't stop there, right? Just like today's seminar theme, they decided to modernize. And so they're moving up the analytics chain from descriptive, which basically means where am I as a driver, right? To predictive analytics, which is where am I headed? And finally on towards prescriptive analytics, which is where should I be headed? And as they do that, their business gains have grown. So let me pause for a second and talk about Velocity, because I've been mentioning it, but maybe people are saying, well, what is this Velocity thing? So at a high level, Velocity is a cloud native capability for ingestion, processing, visualization, and analysis of real-time and high volume geospatial data on the fly. Many words, many words. Just think of it this way. It's just built from the ground up for IoT. So ArcGIS Velocity sits on the edge of Esri's geospatial cloud, right, which is here, right, ArcGIS Online. And it complements Internet of Things, or the Internet of Things platforms, by enabling you to easily bring sensor data into ArcGIS for geospatial reasoning. Now, what that means is it works with sensors that are being deployed out in the field and connected to IoT cloud infrastructures like Azure and AWS. And in this case, Velocity can subscribe to or query these platforms directly without requiring any developer intervention or integration or anything of that nature. And then these sensors can also drive data directly to Velocity over, for example, a REST endpoint. And then under the hood of all of this are three main components that make all of this possible. And the first one is feeds. And here, feeds is what you would expect. It's a sensor feed, right? So Velocity can be configured to ingest any kind of sensor feed that's available out there. Then you've got real-time analytics, and that allows users to perform real-time processing of those data feeds and do things like triggering alerts and therefore different actions based on those alerts. And then finally, you've got the big data analytics, which allows, or for users, what that means is they can access and analyze big data repositories of historical observations. Now, these analytics can in turn generate geospatial content, and the content can be in the form of stream layers, feature layers, or map image layers that can all be leveraged throughout the ArcGIS platform in the form of our client apps, or APIs, or desktop applications to drive additional insight and situational awareness. Now I'm going to stop. I don't need to get into more detail on the Velocity itself, but if you're interested, at the end of this presentation, I'll leave my coordinates for you guys, and I'll be glad to give you more details on it. So let's move on, because what I want to do is start talking about examples of how Velocity is being used in real-world transportation use cases for both real-time situational awareness and big data analytics. So the first example that I chose is an interesting one that would be nice to be there today, is from Oahu DOT. And so let me just click on the image here to start up the application. And let's see here, I'll bring it across so that you guys can see it. There you go. And so what you're seeing here is a situational awareness dashboard view that provides real-time and past 12-hour information on things like traffic data. So you can see here the familiar color schemes that represent traffic that you're used to by now. You have information on transit here. You've got the information on the buses. You've got information on construction projects. And you've got information that's coming in from Waze, which is one of the data sources. And if I zoom in, more layers of information are going to come up. So I can see here, I've got camera information. I can at any time also change this and say, let's say I want to take a look at the last 12-hour data. And I can click on, for example, one of the Waze events, and it zooms me right onto the map. So it's a nice and useful situational awareness dashboard. But what I want to do is, as nice as this is, you can still step that up. And I want to show you how we can step things up through another example. And in this case here, it's Indiana DOT. And if you take a look at this dashboard here, you'll see some of the same components of which Waze is part of it. But I chose it not only because it shows real-time analytics, but also because it fits the spirit of transportation modernization and shows some creative thinking here. So you've got the dashboard from the DOT, and we're using Velocity not only to track what's going on in their own work zone locations, but also to tap into Waze real-time data. And what we're doing is Velocity is monitoring the Waze feeds, and then it's using analytics to isolate and extract those feeds that have the tag accident on it. And it's cross-referencing that with the information about the work zones. And all of that is to determine the number of reported accidents that are located in their work zones. So it's an interesting dashboard, and really it's quite effective when you think about that. It's not that complicated in terms of what you're seeing in the dashboard, but it's a very effective real-time situational tool that really is not a hard thing to implement inside of Velocity and ArcGIS Online. And again, if you want more information on that, we can talk about it at the end of the presentation, or if you want to contact me directly. Now let's switch gears and talk about big data analytics. So we've been talking about real time. Let's do some big data analytics. And here in this proof of concept example, it's the Port of Tampa Bay that wanted to build a security operation dashboard where traffic cameras detect the highest volumes of traffic. But there's a catch here. What they wanted to do is be able to detect and isolate tractor trailer specific traffic volumes. So sift out everything else and let's just find tractor trailers. And that's where big data and AI start coming into play. And so what we ended up doing was to use Velocity to create a workflow where every 2 minutes, we have a notebook server that scrapes the images off the cameras to perform object detection and identify and therefore count the tractor trailers. And you can see examples of that. I'm going to point that out here. Maybe you see them. I'm not too sure if that comes out well in the image, but all of these have got like a bounding box. So these are examples of the algorithm detecting the tractor trailers. But again, this is an example of Velocity pulling together not only real-time feeds, but also performing some big data analytics to help extract usable information from the raw data. So I'm going to do one last example here before the end of the presentation. And this one touches upon using Velocity to help become better at being predictive and prescriptive, which in turn is supposed to help become better at long-term strategic planning. So again, I'm going to click on this to fire up the website. And what you're going to have is a dashboard for pavement quality. And this map shows the combination of the pavement quality index and the international roughness index in order to show areas where pavement is in its worst condition. And you guys know much more about this than I do. But using the information that was collected, the pavement quality scores were generated, which should be used to project a ranking for upcoming construction seasons. So if I click on this pavement project comparison panel on the left, it allows me to see a comparison story map, which looks at raw pavement scores for prioritizing road improvements versus a more holistic prioritization scoring that looks at many other factors than just pavement degradation. And in fact, if I take the control here and I start swiping, the net result is a view like this one, where swiping left to right shows the effects of this more holistic approach to prioritizing pavement projects. But ultimately, if I click here on the project scoring dashboard, it's this one here that pulls the project prioritization process together by allowing managers to evaluate the merits of potential projects by using key factors that include improvements to safety, congestion reduction, accessibility, and critical infrastructure. So I think you might agree here with me that it's a great example of becoming better at long-term strategic planning. And so that, with that being said, it's time for me to wrap up. So today's presentation is just a small example of things you can accomplish with Esri's Velocity IoT platform, as well as some help from our partners, as we showed before. If you'd like to know more about Velocity or what Esri Canada is doing for IoT, you can visit the links that are up there on the slide, and they're also listed on the or in the resources section at the bottom of the event page, so you can take a look at there. Also, feel free to reach out to me in the email address that you see here. And thank you very much for your attention this afternoon. Arif, I'm going to hand it back over to you.
Thank you, Dave. I've got to arrange a conversation for you with my mother-in-law, because I think you've taken you've taken this idea of too much too fast, and you've really shown how you can piece it apart and simplify it to take data and make it prescriptive, take action on it. That's fantastic. Thank you.
And I just realized that last slide that had all the links on it, I didn't put it back up on screen. I stayed on the demo, but They are there in the resource section. Sorry about that, folks.
No, that's fine. Yes, as a good reminder, thanks, Dave, for that reminder. Yes, a lot of the links that are being shared in all of today's presentation are in your resources tab at the bottom of your portal as you're accessing this event. So feel free to peruse those later, and they will be there for you after this event closes. So yes, once again, thanks, Dave, for that great presentation. I want to, again, encourage everyone in the audience to ask their questions. Put your questions into the Q&A box, because immediately after this presentation that I'm going to be sharing, we're going to dive right into that live chat. And I'm going to get all the presenters from this morning back so we can start peppering them with all of your creative questions. But before we get to that, I'm going to share a bit of a presentation here on a topic that's very near and dear to my heart, actually. So of course, the title on the screen says, "Take Your Hands Off the Wheel with Authoritative Data for Autonomous Vehicles." And you may think, okay, so it's the autonomous vehicle part that's near and dear to RF's heart. And it is a little, but that's really not the element that is special to me. It's the authoritative data. Leave it to RF to take the more boring part of this title and say that's the special bit. I mean, it's the autonomous vehicles that's getting all the headlines and all the sexy news articles that have to do with onboard sensors and everything that our good friend Mr. Musk is going to be presenting and tweeting about, and how different manufacturers out there have different advances with all their onboard sensors and how they're one day going to be taking over the world. All that sort of stuff is what hits the headlines. Nobody talks about the authoritative data element of this. And that's why I thought, you know what, I'm gonna talk a little bit about this, because I think it's fairly important. So here we go into a not so sexy part of the autonomous vehicles. Okay, so if you think about it, a common abbreviation for connected and autonomous vehicles is CAV, so connected and autonomous vehicles. As you might imagine, there's a lot of data that they would use. And some of you may be familiar with the terms, right? There's this term called V2V, which is vehicle to vehicle communication. There's also another term called V2I, which means vehicle to infrastructure communication. And that's all kind of been bundled together over the past few years into this concept of V2X, which is vehicle to everything communication. In other words, vehicles need to communicate with the things around them to understand where they are. And the ways in which they communicate, of course, is very different from manufacturer to manufacturer. And as you might imagine, it's an evolving thing. I mean, there's no such thing today as a level 5 autonomous vehicle that's operating on our streets. It doesn't happen, right? It's still a research field. There's quite a lot of level 2 technology that's available in some of our vehicles. You may have some lane departure warnings in your vehicle that allows you to kind of stay within your lane, or a cruise control that's adaptive that allows you to stay a certain distance away from the vehicle in front. These are all assistive technologies within your vehicle that use the sensors on board the vehicle to make decisions. And that, of course, makes sense, right? Because there's going to be data that your vehicle needs, your autonomous and connected vehicle needs, that changes all the time. For example, if you're drifting left in the lane, the car needs to know that you're getting close to the edge and needs to recorrect the course of action. Or if the vehicle in front is getting too close, it needs to be able to recorrect that course of action. Or if there's a cyclist in front of you, the vehicle needs to figure that out so we can actually make a determination. Or it doesn't have to be a cyclist. It could be any sort of object or obstruction that wasn't there a second ago, right? These things need to be identified right away. And so the onboard sensors of a connected and autonomous vehicle, that's what they're there for. They're there to identify that sort of thing that needs attention immediately. But not everything needs to be identified and interpreted right away. There's quite a lot of information out there that may have been there, an hour ago or a day ago or a week ago. And every time a vehicle approaches it, it doesn't need to be interpreted once again in real time. Some of this data can be referenced from an authoritative source. And a good example here, of course, is what I have on the screen. You can imagine this as being a construction zone. Somebody from the Transportation Authority has decided that they're going to, improve a stretch of the road. So they're going to put a temporary work zone in. That temporary work zone, or the location of that temporary work zone, has been entered in a database somewhere. And of course, I'm going to get to the nitty gritty here, but you can imagine somewhere it's been entered into this database. Now, if that database or some variation of it was accessible to autonomous vehicles, one could consider that an authoritative source, and therefore they could reference it and understand that there is a construction zone or a temporary work zone somewhere along my planned route. And so therefore I can determine or make the determination whether I should continue on this route or find an alternative. And I can make that decision all before I ever have to encounter that construction zone. So I'm making a decision before I need to see it, or the onboard sensors of the vehicle pick up that there's a construction zone. And it makes perfect sense, right? You should be able to do that sort of thing where there's data that needs to be identified right away and data that does not need to be identified right away because somebody else has entered that. Now, of course, you get into this nitty-gritty and says, well, this idea of authoritative information source, what is this? What is this information source that's authoritative? Well, if you know of all the different research that's being done right now on autonomous vehicles, there's a number of different manufacturers out there that are providing autonomous vehicles or connected and autonomous vehicles. There's Tesla, there's GM, there's Uber, there's a whole host of them. There's Waymo, and it can be commonly known that as a Tesla vehicle is driving around the streets of the world, it is collecting a database. It is collecting a database, and that database is proprietary for that manufacturer. And they are creating their own information source of what the world looks like. That same, or a different manufacturer is then creating their own version of what the world looks like. You can be sure that Waymo is doing the same thing, and GM is doing the same thing, and all of the other manufacturers are out there with autonomous connected vehicles. They are collecting information because they want to understand what the world looks like. Thereby, they're creating their own information source. Now, I don't know about you, but I kind of find it terrifying if two vehicles that are from different manufacturers are sharing the same stretch of road, and they're approaching an area of that road where there happens to be a construction zone. One of the vehicles knows about it, the other doesn't, or worse yet, one of the vehicles knows about it and the other has a different representation of what that construction zone is. What are those vehicles going to do? I don't know, right? I think that's up to the AIs, the artificial intelligence on those vehicles. But one thing that I know is that one of the ways we can help this is if we have an authoritative source for that type of information that is accessible to both vehicles. Because if we have this proprietary information source, I don't know, to me, it seems like it's the wrong direction to go. And I think it's going to be somewhat of the Wild West out there when it comes to who's right, who's wrong, who's authoritative, who's not. And if you look at the way Canada is today, Canadian road authorities, they've always been the stewards of the data that represents our transportation infrastructure. Again, I mentioned this earlier in this conversation, is that we all use transportation infrastructure because it's a shared system. It's a shared infrastructure. And our governments, our transportation authorities, are the ones who own and maintain and keep that infrastructure in good working condition. Well, it kind of really only makes sense to me that perhaps the data that represents all of this information should be held within a government transportation authority so that it can be an authoritative source that is available to all of the different manufacturers who are going to continue to populate this field. All it needs is a bit of modernization. So let me dive into this just a little bit, and we'll get into what I mean. So this is a map of I don't remember where this was. I think this was Kelowna, if I'm not mistaken. If it is Kelowna, remind me in the chat that it is Kelowna, but I think it was. There's a place called in Kelowna. It's Sutherland Avenue, and it looks like Ethel Street. Now, there's this very interesting thing a phenomenon that I've encountered when dealing with municipalities across Canada. You think about these road representations, and this is just a base map image, but you think about the way that many municipalities take these roads and they maintain a data catalog of these roads. So here's a representation of those roads you can see visually. And this, from my perspective, this peculiar methodology of taking these pieces of roads and chunking them up into what are commonly known as road segments or sections, taking them up and discretizing them into these segments. And then once we have these segments, we can then say, okay, we're going to start putting data onto those segments. Now, again, I find this a bit peculiar because of where I came from, but nonetheless, this is what I see that's being done. So you think about these two sections or these two road segments that have been highlighted on my screen. And I can say that one of these road segments has an ID. In this case, it's 15436. It doesn't matter about the number. The other one has another ID. In this case, it's 15527. But if you look at the different descriptions of these road segments, They both have street parking on them. They both have cycling facilities. They both have bollards, and they both have a partial median. So if an autonomous vehicle were to approach this road or these road segments, does it have enough information based on this authoritative source that it can accurately navigate these streets? I don't know. I have no idea. But I would wager that it would probably want to depend a heck of a lot on its onboard sensors to make sure that it can get there. All it knows is that, yes, we probably have cyclists here. We probably have partial medians, but it's not a lot. And unfortunately, the way that many municipalities take these linear segments of road and chunk it up into discrete assets and start describing those assets, it may be a function of the data systems that were used in the past today, or in the past, to be able to manage these road systems. And to me, it seems a bit peculiar, but nonetheless, this is what often happens to be done. But let's take a closer look into what's actually happening on this road. And here's a satellite image of the same roadway. And I'm not going to zoom in here because this is just a screenshot, but there's a lot going on this roadway. And I'm going to start highlighting it. One of the first things I'm going to do is I'm going to highlight these intersections. You notice that I put these little orange boxes on these intersections, and I'm going to say that they occur at certain locations. We know the spatial location, but I'm going to augment that spatial location with what's known as a linear measure. So I'm going to define that on the road of Sutherland, I have this direction of increasing measure, which goes to the right on your screen. And if that's the case, then the location of those intersections, you might imagine, as we proceed to the right or to the east, increases in measure. So that's why I have the first intersection at 370 meters, another one at 782, and another at 892. Now, if I put this datum in place, this idea that I have this calibrated road at Sutherland, then I can start peppering it with all sorts of very accurate descriptions of what's going on the street. I could start popping down streetlights at their individual location along that street. I could start popping down those bollards that we know exist, right? And accurately locate the measures in which those bollards exist. More than that, I can start identifying where that street parking actually exists on those pieces of road. So it's not the entire section of road. It's clearly just from, well, in this case, 437 meters to 697 meters. So it's a piece of road. And there's another bit just to the other end or the east of that middle intersection. And then in addition, I also have a protected cycling lane. We know that, but now I know the extent of that cycling lane. And because of the detail I have, I'm also able to identify that, you know what, the first one was protected. The second cycling lane here is a shared cycling lane, and I know the extents of that. Now that I'm able to actually identify where things are, I can use this another feature that allows me to use a different location referencing method. So rather than actually referencing the actual location of these things, I could start referencing stuff based on other things that I have. And here's an example of that. So here we know that as you approach an intersection, there's going to be a turn lane. And in this case, I've identified 3 turn lanes on this street in Sutherland. And one of them is 40 meters, the other is 55, and there's 40. Now, in isolation, 40 meters doesn't mean a lot, but if I'm referencing it to the intersection, now suddenly I know exactly where that turn lane begins and where it ends and where it exists in real life. And I can do the same with the medians that happen to exist on both of those street segments. So if you look at this data now, this representation of that data, let me go to the next one so you can see it. It's a lot more information, but note that it's much more accurately located on my network. And so the question I would pose you is that if an autonomous vehicle, heck, it doesn't even have to be an autonomous vehicle anymore, right? It could be a human-driven vehicle, but the data, the way it's represented, this, I would argue, is far more clear, and I can make more sense of this. I could do more with this kind of data than I can with the other. I would argue that's the case. And I think if we're going to get to a place where Canadian transportation government authorities are going to be offering an authoritative representation, a data representation of the road network in order to support things like autonomous vehicles, we've got to get more detailed with how we manage the assets on our roads. And I would also argue that the way we collect that information, it's not hard. It's just a matter of how we store it. So one of the takeaways I have here is that transportation networks, they're linear in nature, right? They're inherently linear. We're talking about roads that go from one end of the city to the other. We're talking about paths. We're talking about rail sections. We're talking about sidewalks. These things inherently have no beginning and end. And so we have to stop thinking about them as discrete assets. They're not discrete assets. They're linear assets. And lots of things happen along various lengths of that linear asset. So we cannot use a system that has primarily been designed for discrete assets to be our asset management system. I, for one, firmly believe that. And I think if we're going to be able to modernize, we've got to start treating transportation assets for what they are. They are linear assets and they're very complex. So we got to use the tools that are defined to be able to manage those types of assets. Right. Second, you need to be able to interpret that data using multiple location referencing methods. And I gave an example of this, right? I showed how these assets you saw in the intersections, they are located by a measure, but not everyone understands what that means. I need to be able to locate this by a GPS receiver on my vehicle. I also need to be able to locate this by a reference offset. So knowing where my intersection is and saying 50 meters away from that intersection, I need to be able to reference it from an offset from a road sign or an exit ramp on the highway. It doesn't matter. The point is, I want to be able to reference a common referencing system using multiple location referencing methods. And the key here, well, one of the keys is that it can be either human or machine. And humans have the ability, of course, to interpret things. Machines have a rather limited ability to do that, but artificial intelligence is getting better. But why place the load there? It's not all that complicated to devise data management systems that can be interpreted by machines today. It just takes a little bit of effort to put these things together. And finally, and this is kind of where I started off, the idea that different manufacturers are out there, because we know that the companies who are contributing to the autonomous vehicle space, there's plenty of them, and there will continue to be plenty of them. There's going to be thousands of them. And again, I'll say it, it's frightening to me if they have their own view of what the world is, because again, it's a shared system. And in a transportation system, not only is it shared, but there's lives at risk too. Road safety is an incredibly important element of our transportation system. People lose their lives on this system, and that is unacceptable. And so if we all have different views of what this road network is or what the transportation network is, I see a missed opportunity in trying to chip away at this problem of road safety. If we have a representation not impeding on any of the proprietary nature of these individual companies, but by providing an authoritative representation that all can trust, I think we'll find ourselves in a better position to be able to embrace this potential future of autonomy as we get closer to it. All right, so we are at the live break time. And I hope while I was talking, some of you have been putting some questions into the QA. If not, here is your opportunity to go ahead and start popping some of those questions in, because I'd like the opportunity to bring back all of the speakers. So I'm going to stop sharing my screen, and I'd invite our speakers from the morning session to come back, turn on your cameras. Thank you very much. That was an excellent morning. First half. Maybe for some of the listeners, it is the morning, but that was an excellent first half of the presentation. Thank you all for those wonderful presentations. And why don't we dive right in to some of these questions? Okay, and as I'm going through them, please upvote, add your own. If we don't have the opportunity to get through all of them, right, we'll get through all of them again in the later half of the session. All right. So the first question that I have here, it's got the most upvotes. So I'm going to go ahead and ask this one, okay, without even knowing what it is. And it looks like this question might either be for David or Lindsay. So either of you go ahead. It says, can BIM models of proposed or ongoing development projects be imported into ArcGIS Urban?
And I'm thinking by David, you mean not me, David.
Not Monahan. Yes, I'm thinking David Kosowski. David, Lindsay, please.
I feel like, David, you could probably elaborate more on the answer. My answer would be yes.
Sure. So yes, to answer that question, BIM models can be brought into ArcGIS Urban, and they can also be published into ArcGIS Online. So to not go into great detail about the workflow here, we pretty much would bring in the BIM model or the Revit model into ArcGIS Pro and then publish that as a building scene layer package. And once that building scene layer package is published into ArcGIS Online or into your organizational account, you can view it in the web viewer. And then there's a really cool feature that ArcGIS Online provides where that's called the Building Explorer tool. And the Building Explorer tool is kind of like a drop-down menu that allows you to filter and visualize the BIM model in the kind of ArcGIS or Esri viewer, and start to explore the inside and outside and the different sort of exteriors and interiors of the building. And so that functionality is built into ArcGIS Urban as well. And so it's a great way to bring in your proposed developments into that urban environment so that you combine those kind of more realistic development proposals with those massing models that Lindsay showcased in that scenario build out.
Yeah, thank you, David. I find this an interesting time, actually. So for those of you, I'm sure everyone knows what BIM is, but if not, it's building information management, and it's a description of the way that data within a building is housed. And I find this a very interesting time because we in the industry, we're constantly hearing about BIM, we're hearing about CAD, we're hearing about GIS, and in the transportation space, it's primarily CAD. I mean, I don't know, Lindsay, would you agree with me in the transportation space is primarily CAD? So this kind of confluence or this idea that CAD, GIS, BIM, they're coming together finally. Is this a good thing, you think, Lindsay?
Yeah, this is a great thing, both in terms of improving the workflow and making that more seamless, and also taking all the information that all these different platforms specialize in creating, bringing all that information together. So it's really exciting, and it gives designers, engineers, planners, it gives everyone so much power to take ideas so much further.
Absolutely. I think that's fantastic. Okay, let's go on to another question here. Oh, my screen just updated. My apologies. Here we go. Okay, so I'm going to assume this is talking to you, Dave Monahan. It just starts off with you. It says, you've indicated that Velocity is a SaaS or software as a service offering on ArcGIS Online. Our DOT, Department of Transportation, is not currently allowing us to use public clouds. Is this available on premise?
Yeah, so that's an interesting question, and we actually get that quite often, and they're not alone. Many DOTs, and in fact, many other government organizations that are out there are faced with the same kind of scenario, and or I would say to some extent policy, right, that says we just don't do that yet. We're not ready for all kinds of reasons, right, that we understand. The answer to that question is yes, we do support that. There is the option to have all of this on premise. And in fact, because of some of the issues that our customers did raise and have been raising for quite some time now along those lines, it has in fact prompted the whole development team for Velocity, which, as I said, is on our cloud environment, which is the public cloud, to take a look at that and say, can we take Velocity per se and bring it on premise? Because we already have an on-premise offering, but Velocity is built from the ground up on cloud technology, and in fact on Kubernetes. And because that's the case, that allows us to say, hey, if you've got an enterprise license, for example, and you want to bring Velocity inside, then we're looking at the ability to do exactly that. So take Velocity off of the public cloud and bring it right into your organization on premise. So certainly it is a configuration that we can support for our customers that have got that kind of scenario.
Yeah, that indeed is exciting to me, Dave. I mean, we know that there's going to be privacy concern from a number of different entities. And so being able to accommodate that without, putting their data at risk is extremely important so that they can have their cake and eat it too.
There you go.
All right, this question, perhaps I'll direct it first to you, Lindsay, and then David, you can perhaps follow up on this. So parking space flexibility seems to only become available after the required minimum is reached. So when you were doing your demonstration, Lindsay, there was this idea of minimum parking requirements, and when you surpassed it, then we were able to be flexible with what you can do with that space. So do you think that urban configurations should continue to be driven by minimum parking requirements?
No, I think this is where the discussion really comes in. I think that when you start looking at how this overall model looks and how these spaces look as a whole, you start to realize that maybe there's alternatives to how we explore parking requirements and those minimum parking requirements, and maybe and it comes back to those questions we had at the end. Is this the future of the city? Is in 10 or 15 years, are there going to be as many personal automobiles? Are people going to use car shares more? And so taking urban and the models we create in urban and these metrics as well, and looking at them, maybe reconfiguring those minimum parking requirements to reflect cities 10, 15 years down the road and the needs of future cities.
There was, growing up, I was a big video game fanatic. There was this particular game that I really loved. It was called Baldur's Gate. And the reason I'm mentioning this is because I was lucky enough to witness a speech by one of the executives of that company who developed that game. And the game was a success, so he's done very well for himself. Anyways, he lives in Edmonton now. Or actually, I don't know now, but at the time he lived in Edmonton. And he opened up a bar. I think it was a restaurant or a bar or a cafe. And I'm getting to my point. But the reason he opened up this bar, restaurant, and cafe was something that he wanted to do. But he was also a proponent of abolishing this requirement of minimum parking. And so the story that he was sharing at the time was that because of the size of the bar that he had opened up in Edmonton, he had to put, there was a certain minimum requirement for parking, but he did not want to abide by that. In fact, he wanted to encourage cyclists and people to come on foot because the neighborhood in which this bar was located was very accessible to transit and foot traffic. And he felt it wasn't necessary to put that much parking. And he fought the city at the time, and he won. So he was able to get that establishment in place without the minimum parking requirements. And I don't know the details too much behind this, other than the fact that he was able to do this. But to me, that's a sign that in pockets of Canada, in this situation was Edmonton, these rules can be considered sometimes archaic. So maybe there are ways to get around them, and maybe change some of the policies that are in place so that we can improve the way that future establishments and urban configurations can be brought down so that active transportation can reach them. David, do you have any thoughts on this topic? Kosowski.
Yeah, thanks. Just to kind of add to the point, I think the one thing that's really challenging that would be amazing if it could be done is to really think beyond the parcel level. Minimum parking requirements at a kind of per development level is something that doesn't necessarily consider or fix these future issues that we're dealing with. And if we can think about shared allocation of space that go of adjacent parcels, or if we think about designing for the street to start to allocate shared parking spaces there, and bike parking and any other sort of vehicle parking, I think that would really start to improve the way that we can really start to design spaces in our cities, especially as we're increasing densities and the demands of space for human use and not just car storage are starting to increase. And if we're thinking about that future transit situation where we maybe are looking more into that automated vehicle or even self-driving car kind of world, it really does start to open up the kind of the world to these new ideas of what does parking look like in that future city, and where do cars actually go if they don't need to necessarily be next to where the person who owns that car or who's sharing that car is leaving that car for the day. It could actually drive off site and come back and return to you later on in the day. So it does open up this whole new world of thinking about what does minimum parking look like, and what does parking look like when we think about kind of sharing space beyond that parcel level.
There's a lot of data that I can see contributing to these kind of decisions. And Dave Monahan, earlier, you're talking about too much data and making good sense out of that, right? Data rich, information poor.
Yeah, and
in this context, Dave, do you think real-time data, and perhaps even ArcGIS velocity, but more importantly, do you think real-time data can help address and help us become more prescriptive for managing parking spaces or the curbside or drop off. Do you think that real-time data has a role in this realm?
I think it's actually a combination of not just real time, but also big data analytics, because the whole big data analytics component can actually be used in that planning process, right? To analyze based on historical data, the traffic patterns, right? And figure out if in fact things like, minimum parking requirement is actually, not relevant, but to what degree it is relevant for a specific facility based on its function, right? And so the big data analytics may say, hey, no, for this kind of facility, you don't need to have this minimum requirement. So that's on the big data analytics component. The real time can help to, in essence, kind of validate that, right? By reporting on, of course, what's going on real time in the traffic, and validating if some of that big data analytics was in fact correct, and if corrective measures need to be put in place to accommodate for that. Because the one thing that's going to happen is, and that's guaranteed, things change, right? And because things change, you have to constantly adapt, right? And be able to be proactive, to be able to have that prescriptive and predictive capability, right? And so that's what this technology is meant to address. So yeah, it absolutely does have a role to play, but on those both plans, so real time as well as big data.
Excellent. I couldn't agree more. Okay, so I did have another question here that actually got a few upvotes, and it looks like it's for me, so I'm going to go ask the question. It says, our organization still uses linear referencing on its highway segments, for example, for lanes, pavement condition, etc. Do you consider linear referencing systems outdated in a modern transportation GIS? We will be transitioning to a new system over the next few years. Okay, I've seen this question pop up before. The idea of using linear referencing has been around a very long time, decades even. I think the very first data systems that managed highway systems were linear referenced. And of course, I wasn't around back then, or in the industry back then. I can only guess as to why that was the case is because, data storage was at a premium. It was very expensive to hold data. And so it's extremely efficient to reference things using a measure value. And that way you can store the locations of stuff. Even this is before the days of GIS, when you actually had accurate methodologies to store spatial locations, you'd use linear referencing. And so the question implies that it's outdated in a modern transportation space. And so my argument to that is, yes, it's a very old system, but old, just because it's old in my view, doesn't mean that it's outdated. I think the concept of anchoring your data to some sort of datum is incredibly important, particularly if you're operating in a shared space. So if the only data that you're holding is your own data and you're the only person who's managing it, and everything is within your control, then you can use whatever system you want. Frankly, it doesn't matter. But the beauty of linear referencing, beyond the idea of saving space, was because it's a simplistic way of referencing things. And the methodology in which you reference can be extended to anything, any machine, any system, any downstream business activity. And due to that complexity, it's a very natural way to integrate data. So does that make it outdated? I don't believe so. I believe it has a lot of power, especially when you take that concept and you integrate it into a spatial GIS. This is now a GIS-driven, three-dimensional driven linear referencing system. And if you do that, if you put these two elements together, understand that it's been designed so that the transportation space or industry in general can now reference things, anything, speed limits, traffic changes, pavement condition, location of bollards. It doesn't matter what the thing is, but if you can reference it accurately, not in general space, like what vanilla GIS is, but reference it to a location, a very discrete location on that road network or transportation network, then that reference can be read by anybody, not just GIS. And that right there is the power, because you have the ability to utilize GIS systems and any other system out there, CAD, BIM, if we have it, so that you can use that reference location for whatever downstream business product. So I'm sure there may be people who argue with me, and I'm encouraged to get into a conversation about this, but right now would not be the time. I'll definitely do this over a beverage, perhaps another day. But no, I don't think it is outdated. In fact, I think it's more needed now than ever. But we are at the time where we should get into our next presentation. So Lindsay, David, and Dave, thank you very much for your morning presentations and participation in the live chat. We'll see you again at the end of the session. If there are more questions for Lindsay, David, or Dave Monahan, please don't be afraid. Put them into the QA box. And if we have time at the end of the session or at the end of the seminar, we will readdress them. These wonderful faces will be back to share their glory with us then as well. So thank you all.
You're welcome.
Our next presentation, and he works very close to where I live. I actually live in Scarborough, and Stephen Farber is a professor of human geography at the University of Toronto. And he's going to be sharing a presentation with us today on transportation equity, analysis using integrated data. So I'd like to take this opportunity to invite Stephen Farber. If you please turn on your camera and turn on your microphone. Go ahead and introduce yourself.
Sure. Hi, everyone. Very pleased to be here. And thanks for that introduction, Arif. I'm very, very happy to be here and looking forward to the rest of the talks on this panel and also to our discussion later on. I'm going to start with a bit of a rhetorical question around what people think transportation planners or transportation planning should focus on. Over the decades, the mandate of the transportation planner, I believe, has expanded very much. We have such a breadth of expertise and a breadth of desirable outcomes that we're all planning towards. Everything from network efficiency, freight, urban and economic development, trying to deal with big data, new technologies, and all the while managing the externalities of the transportation system, safety, pollution, health, and the looming climate crisis. And of course, we have to be focusing on all of these things, but really missing from this mix is people. And I asked the question, what about people in transportation planning? And I would like you to all consider that one of the ultimate, fundamental purposes of the transportation system, in particular the urban transportation system, is to enable people to participate freely in the activities of daily life. But this core objective of enabling participation in daily activities isn't actually on the desk of any planners that I know. This goal has been sidelined. Sidelined is a bit malicious. It doesn't have to be thought of as a malicious sidelining of this goal, but we've really been focusing on achieving mobility, managing externalities, economic returns on investment, and so on, and really been measuring and planning towards all of these other goals rather than planning more directly towards this goal of achieving fair, equitable participation and access to daily activities. And I asked the question, do we know how to plan towards achieving this participation objective? And do we know how to do this in a fair way, in a just way? So these are all some of the questions that I'd like to get into through a specific case study, a research case study that I've been participating in. But first, a bit of background. What is transportation equity? I think the easiest, simplest definition out there is transportation equity is about the fairness of the distribution of the costs and benefits of the transportation system. And in fact, this very simplistic definition gives rise to many of the core basic questions around transportation equity, like what are the costs that we're measuring? How are we going to measure the benefits of the transportation system? What are those distributive population groups? Should we be considering rich versus poor, white versus racialized populations, long-term residents versus new immigrants? How are we going to divide the population up into these different groups? And then once we've done that and we've measured how different groups are paying different costs or receiving different benefits, how are we going to decide what is fair? What are we going to do with all this information? So I would say that a lot of academics right now are very much engaged in answering all sorts of flavors of these four core questions. And in many ways, if we think about the benefits, one of those benefits being the ability to participate in daily activities, you see that how we can connect my previous slide, right, to this whole notion of equity. What we're trying to do is have a provide a fair distribution of abilities to people in the transportation system. And I love this one theoretical slide to get us grounded and on the same page. And this is a slide that describes something called the Transportation and Social Exclusion Framework. And the idea here is that when people are both socially disadvantaged, so traditionally kind of considered to be in low socioeconomic status, and at the same time living with transport disadvantage, so perhaps living in a place with poor levels of service provision, not owning a car, maybe transit's unaffordable or there's crime and they're unable to get information that they need about the transit system and so on. But when these two forms of disadvantage combine, we say that people are living in transport poverty. And it's okay for Arif to live in Scarborough and a fairly poorly served part of Scarborough when it comes to public transportation, because he's got a good job at Esri and he has enough money to buy a couple of cars for his family. And that transport disadvantage doesn't actually result in a problem for him and his family, right? But when you're both socially and economically disadvantaged and transport disadvantaged, this is where people really start to feel the pinch. And being in transport poverty means that you likely have lower levels of access to the destinations of daily life, whatever that means: work, school, healthcare, social capital, shopping, healthy food, voting in an election, going to town halls, extracurriculars. So we're not talking about just any one specific kind of activity here, but broadly speaking, this disadvantage leads to suppressed levels of participation in all sorts of activities. And over time, that leads to a condition of social exclusion, which is, people participating in fewer types and numbers of activities compared to the norms for society. And my work over the last few decades has really been studying all these different arrows in this plot. I mean, it's kind of sad for me to say that out loud, but in a lot of ways, that's what my career has been, what I've been doing in my career is trying to understand all of these flows and these relationships. And now moving more and more into what kind of interventions can we make? How can we use a fare program to make transit more affordability? And what does that result in as it flows through this pathway, right? Does it result in more participation and less exclusion? Or if we're more in the technology space, how can an on-demand transit subsidy or an on-demand transit system generally reduce transport disadvantages for low-income people and result in better social outcomes, right? So doing lots of work in this area. So why am I telling you all about this? This is all really, really important in Canada specifically right now. Mainly, I see two kind of trends in Canadian cities that point to this being kind of sitting on the edge of a perfect storm. And that is, we've got growing levels of inequality in this country. So we have polarization. The wealthier have been getting wealthier. The poor have been getting poorer, relatively speaking. And inequality across most cities has been on the rise for more than 30 years now. The other thing is we have a kind of social geographical trend, which is that we see that the better served parts of our cities, the areas of our cities served by subways and rapid transit lines, are getting wealthier over time. And our aging car-oriented suburbs are actually getting poorer over time. And, I'll show you some maps of what that looks like too, but based on our accounting, across 8 Canadian kind of major metropolitan areas, we see as many as 1.3 million Canadians living below the poverty line, also living in very poorly served parts of cities when it comes to being able to access destinations locally or via public transit. And these trends are on the rise. So these numbers are from 2016, but of course, if we think about what the 2021 census will show us, and layer on top of that the tragic impacts that that the pandemic has had on the Canadian population, especially kind of the low-income population in this country, we're going to see these numbers on the rise. And that means we are likely going to see more and more people, low-income families, living in suburbs with poor access to destinations, and more people at risk of social exclusion due to this kind of transport poverty that they're going to be at risk of. So we wanted to develop a baseline in based on the 2016 data. Can we quantify, well, we've already kind of quantified how many people there are at a national level at risk of transport poverty, but now we want to see, how does transport poverty actually relate to differing levels in daily activity participation? So to do that, we're fusing together a few data sets. The first is we generated a measure of accessibility, and we used jobs as our proxy for accessibility. For, you know, where jobs are located, it's usually where all sorts of goods and services and even healthcare is located as well. It's not a perfect match, but it's highly correlated. So we have this access to jobs measure, and the map is showing you how many jobs are reachable within a certain travel time threshold. And I don't want to get into equations and everything, but we do this using a gravity-based accessibility model. So for any given location, nearby opportunities are weighted higher than opportunities farther away. And it's all based on travel time, expected travel time through the transportation network. On the other side of the equation, we have people's activities. And here we're measuring participation in daily activities using a survey called the Transportation Tomorrow Survey, which is one of the world's largest household trip diary surveys. And it's for the entire Greater Golden Horseshoe area, you know, focused on Toronto. And out of this survey, we have a very large sample of people's daily activity patterns, and we can quantify how many trips people made, how many out-of-home activities people made, and how many discretionary activities people made on a day. Discretionary being non-work and non-school trips. It's a pretty blunt definition. And this just shows us different kind of daily patterns and how that relates to different activity outcomes. But now we have the recipe, the ingredients that we need to kind of see how these activity patterns are related to this accessibility level being provided by the transportation system. So first of all, a map. Most of my maps that you're going to see are made by one of my PhD students, Jeff Allen, who's going to be graduating this year and looking for work, and he's fantastic. But he made, so this map is showing you that accessibility score. You can see, obviously, that the access score is a mixture of kind of being close to destinations, like employment destinations, like by the airport or by downtown, but then also the transit network here is really the thing that allows people to reach these activity destinations. Layered on top of that are these black dots, and each black dot represents 50 people living below the poverty line. And what we see in Toronto today, or actually in 2016, is that about half of the population living below the poverty line lives in these kind of darker purple areas, right? So we still have quite a lot of people living in poverty in the inner city, but a full half of the low income population is living out here in the suburbs of Toronto as well, in the beiges and these white areas with almost no transit access to destinations whatsoever. And when we layer on top of this, the people's participation patterns, what we find is these clear clusters that come out of the data, clusters of low activity participation. I like to call these participation deserts. These are big areas of the city where all else being equal, people are actually doing fewer out-of-home activities on a daily basis. And where do we see these clusters? They're occurring at the intersection of low incomes and fairly low transit accessibility levels. So in the inner city where we had half the low income population, yes, incomes do suppress participation levels, but we don't see nearly the extent of that concentration of lower participation levels in the inner city because the transportation system and the local access to destinations is not a problem for a lot of people living in the inner city. It's out in the suburbs where low incomes and poor transit access intersect that we actually see these big pockets of suppressed participation in daily activities. And of course, we've modeled this left and right. We've done all sorts of regressions that I'm not going to bring into a talk like this, but I really do want to point out this one plot. And specifically around car ownership being the key variable here that differentiates what people can and can't do if they're living in a low access neighborhood. So this gap between, say, the black line here and these lines down here is the kind of the normal level of participation across all respondents for people who are living in these super low access neighborhoods. We see they're doing about 1.25 activities a day, whereas these these carless households in the same kind of neighborhoods are doing only 0.5 activities a day. So like a 0.75 gap in daily activity participation, which is very significant when you think that the average is 1.25 activities a day. So a lot of isolation, a lot of exclusion. And as we look at households, as we move into higher and higher served neighborhoods, what we see is that gap between carless households and everyone else really starting to disappear. And about over here, actually, if we put error bars on these plots, we'd start seeing very little statistical difference between these different groups in terms of how many activities they're participating in. So in fact, investing in transit is a wonderful equalizer, right? In terms of providing opportunity to carless households and low-income households to participate in normal levels of activity participation. And we've done a lot of studies, like I said, saying, so where should we be investing based on this information? What kind of return on investment will we get in terms of the return being measured in unlocking people's ability to go out and participate in more activities per day, whatever those activities might be. But I'd like to wrap it up now and just talk about data integration and how much data goes into a fairly straightforward analysis like this. At least it's presented to you as a straightforward analysis. But of course, lots of demographics data, very large sample travel surveys, the very sophisticated processing of transit networks and road networks being done to compute those accessibility scores. We need to have lots of access to land use and urban form data to understand the local access or transit-based access to different types of destinations in the environment. So, all of this data, I would say, is kind of static data that we've got in our hands on and been able to use. But, we are missing all sorts of information from this analysis. So, for example, our travel survey data comes once every 5 years, and it's not very rich in terms of social and economic indicators. So how can we integrate new data sources in order to have more frequent measures of the participation system, or even ubiquitous measures of travel behavior based on sensors and GPS? And how do we enrich that data with knowledge about who these travelers might be, which is so fundamentally important to doing equity analysis, right? when it comes to the transportation system, we're using these snapshots. Esri provided us with the project of congested roadways, and the transit networks provide us with their schedules. But of course, we know that in the actual experiences of people don't really mimic what we're measuring in these static open source data sets, right? Or even the proprietary data sets. So based on some studies, we've seen those accessibility scores fluctuate by plus or minus 25% on any given day for some neighborhoods in the city, based on just what's happening on the bus network, how fast are the buses moving, whether or not there were missed trips, short turns, all of those operational things we'd like to be able to incorporate into more nuanced measures of the transportation system. One of the big pieces of missing data that we have is we only get to see what people do. We never actually get to see what people don't do. So because of that, we really don't have good measures of immobility, the opposite of mobility. How often are people just staying home because going out was too difficult for them that day? Or how do people experience barriers or constraints in the transportation system? None of our surveys, none of our data sets really allow us to capture those types of nuances, and we would really like to collect and integrate that kind of data. And then finally, when we speak to decision makers, it's really all about the outcomes. How could we rewrite our analysis so that at the end of it, the decision maker knows, how is this going to move the needle on the employment rate? How is it going to move the needle on the college dropout rate? How is it going to move the needle on how many late stage cancer diagnoses we're going to find in the healthcare system, right? Because people no longer, are skipping those screening appointments because of the inability to get there on the transportation system. And we really need all sorts of outcomes data linked to all of this in order to close that last gap. So I'd like to leave you with these thoughts, with these open questions, with ideas about how we might move the needle forward here on equity analyses based on these data integration needs. Thanks very much for your time.
Thanks, Stephen. The early part of your presentation reminded me that I should actually add an element to the resources page for everybody. And I think I should put a link in there to Steve Farber's GoFundMe page to make sure that he gets a light rail transit spot right in front of your house. Okay, so remind me.
I got it. I'm not the one who needs it, unfortunately, but yeah. Thanks, Arif.
Oh, but in all honesty, that was fantastic, Stephen. And seeing all that data that Stephen and his team has been able to put together, I think, like, for me, it feels like we should be, and perhaps we are, but I think we could be doing better at using some of this data so that our transit investments aren't necessarily too often politically influenced, and actually used real data to be able to get to the people that really need access to transit. But thank you, Stephen. Let's get to our next presentation. And our next presentation is, one second, flip my slide, there we go. By the Director of Policy at the Toronto Region Board of Trade. I would invite Jonathan English to turn on your camera and your microphone. Jonathan's going to be sharing with us a presentation on reimagining and reforming urban mobility, which I think, of course, is very timely after Stephen's talk. So, Jonathan.
Hi there. So I'm Jonathan English. Hopefully this is all coming through adequately. I am the Director of Policy for Transportation at the Toronto Region Board of Trade. I have the great privilege of coming after Stephen Farber because I think, while it's a tough act to follow, I think that the theme is very much on point. One of he's done a really good job about talking about and revealing the challenges faced for mobility, and particularly for access in suburban areas, and highlighting the suburbanization of poverty, especially in the Toronto region, but this is something we're seeing across North America. And it's really high time that we address this. So I'm going to talk a little bit about building transit ridership in suburbia and looking at a few success stories. I'm going to start by going back into the past to talk a little bit about how we got where we are today. And then I am going to look at some more current examples and look at what that has meant. So, to start off, the overall, thesis of this argument is that transit demand is really driven by transit service. And the level of transit service that is available will go a long way to determining how many people ride it, which means that there is a bit of a chicken and egg problem. So, when I say very quickly, what is service? I think there are a few different things that all come together to form what I'll use the word service to describe. One is coverage. How much of the region can you actually get to with the transit network? What does your route map look like? The second is frequency. How often do the vehicles come? You may have a route past your house, but if it only runs in rush hour, it isn't necessarily going to be all that useful to you to go visit your grandmother's after work. The third is span. Again, how much of the day does the service operate? Does it operate late in the evening? Will you be able to get home if you're working late? Speed. Now, particularly average speed. How long does it actually take you to get from point A to point B? Fares. Are the fares reasonable for the journey that you're making? Do you have to pay a lot more, for example, for a transfer? A transfer is an inconvenience. You shouldn't necessarily have to pay more for it. Accessibility. Is the service accessible to everyone, whether those people have disabilities or other issues? Approachability. Is it easy to understand, even if you're a new rider? And connectivity. How easy is it to switch between modes, between operators, et cetera? So, having established what I mean by service, let's go back a number of years and let's look at the example of what's now the city of Toronto. So in 1953, the province of Ontario created Metropolitan Toronto. It took over the local transit agency, the TTC, which had been run by the city since it was municipalized in 1921. Now, one of the things that happened, and this sets the city apart from other parts of North America, is that the service area of the agency expanded overnight from 35 to 240 square miles. But the legislation still said that it had to be a self-sustaining operation financially. Now, why am I going back into the past? Well, I think one of the things that's really important to look at is that Toronto is the only city in North America that actually grew transit ridership from the Second World War to 1970 at the height of the auto building suburbia growing era. Now, what's really striking is that from 1952 to 62, Toronto was a pretty ordinary place. It wasn't all that special in terms of its transit ridership performance. Ridership as people bought cars dropped by 37.5 thereabouts %. Not much different from Chicago, Washington, and Philadelphia, all around 40%. What really is different and quite striking is what happened after that. So you can see in comparison with the US national average, Toronto dropped, if anything, at a slightly higher rate than some parts of North America from 1950 to 1960. But then suddenly it was able to turn it around, flatline, and then actually grow per capita ridership in the 1970s and then into the 80s. In the US, the decline happened, but then the decline just kept on going and never was able to be reversed to any significant degree. And what's the upshot of this? So Toronto has the highest transit ridership per capita of any place in North America aside from New York. And of course, New York's not a fair comparison because the 5 boroughs, which are served by the NYCTA, are almost all developed, few areas aside, before the war at much, much higher density than the Toronto service area, which is mostly post-war suburbia. So you look at this figure, the TTC figure really is much more comparable to an operation like Los Angeles, like Dallas, like Detroit, or not even Detroit actually, like Houston. the difference really is quite striking. So you can see here, it was really quite an abrupt turnaround. Steady decline. And then suddenly in the early 1960s, an abrupt recovery and a shift to growth. So, what happened in 1962, 63 to produce this dramatic change? So first, I want to say that Toronto is a fairly typical, in many ways, as certainly was at that time, North American area. When you look at Toronto's prototypical suburb of Don Mills and Levittown, New York, the kind of classic American post-war suburb, your eyes would be better than mine if you could say which one was which. But what did happen in 1963 was a radical expansion of transit service to the newly built suburbs. The genesis for this was as much as anything political. But to everyone's great surprise, people actually rode all these new routes in bold color on this advertisement that the TTC had from 1964. People were quite stunned, and in fact, so many people rode these routes that the new routes actually made a profit, which is pretty unusual. They certainly weren't expecting that. And building from that, the success of these routes resulted in the addition of more and more service as new areas were built, and it put the city into what you could say was a virtuous cycle of improved service, improved ridership, which really was quite unique in North America. The agency went from a loss of $2.5 million to actually a $3.9 million profit after it expanded service to the suburbs, while the expenses rose by over $1 million to add service. Revenue actually rose by $6 million. And despite and all of that revenue growth came in the suburbs, the ridership exclusively within the old city actually declined, but it was made up for by huge growth from people coming in from the suburbs. Revenues were 3% higher than budget had projected, and then they continued to increase over the subsequent years as more and more service was added. So what is the upshot of all this history? Well, the upshot is that Toronto to this day, although that virtuous cycle kind of came to an end at the end of the 1980s, and we've been treading water a little bit more ever since. The upshot, nevertheless, is that transit's mode share in the suburban parts of the city really isn't all that much lower than it is in the downtown core. And this sets us completely apart from an American city, where a 29% mode share in the old city isn't all that much different from a Washington, a San Francisco, a Boston, those kinds of American cities. It's well within the ballpark. But to get 23% in a place like North York, while it has some dense areas, predominantly a single family and in many areas relatively affluent suburb, is unheard of. And you could say, is this a population density question? Is Toronto that much denser? Well, North York and Etobicoke aren't really much denser than Los Angeles, and they're in fact quite a bit less dense than Santa Ana, which is in Orange County, and does not have particularly high transit ridership. This is a picture that I've often shown to a couple pictures that I've often shown to American audiences. A street with strip malls, backyard fences. You look at it from the air, it's kind of cul-de-sacs and single family houses, places with pools in the backyard. What kind of transit service would this road up the middle receive? And without exception, the Americans tell me either none at all or once an hour. This isn't the kind of area that you would conventionally see as transit supportive. But this road is actually one of the busiest bus routes in North America. It's busier than all but a handful in New York City, the city proper. So, so what happened? Well, what's striking is it has 44,000 riders a day, 39 vehicles operate that route at peak. What happened is that better than every 10-minute until 1 a.m. service was provided, and it has been provided for decades. And as a result, people, even though they live in a house and can afford a car, and if you know Toronto's real estate market, these houses aren't cheap, they choose to use the bus. Why? Because they don't have to wait long. It might not be fast. It might not even be all that reliable. But the fact that it does come all the time has made a huge, huge difference. You know, it has more riders than even a busy downtown streetcar route. So, you know, what this shows is that good service with good fare recovery, it actually has a lower cost per rider than the downtown streetcar route. It is possible in the suburbs. You know, Toronto adopted a set of service standards that frequent transit must be within 90%, within walking distance of 90% of the population, and employment 7 days a week. So this is a legacy of many, many decades ago that the city hasn't necessarily built on. But nevertheless, when you compare it to other parts of North America, look at a place like Nassau County, which is on Long Island in New York, which, you know, it's New York. It's not a place that's historically hostile to transit, but nevertheless, this is a fairly typical example of a bus route on a Saturday. You know, the buses come once an hour or even less often. On this route in Memphis, the last bus leaves at 6:15. So it's not surprising that people that have no choice but to ride transit are deeply, deeply limited in terms of the choices that they can make, in terms of the trips that they can make, and anyone who has a choice won't use the transit system. You know, so this is another example. You know, you look at TriMet, and Portland is not a city that is known for having a weak transit system, but nevertheless, you look at the map of Portland's bus routes and light rail routes, and it looks pretty impressive. It covers the whole region. But then when you actually look at how many routes run even as much as every 30 minutes until midnight, 7 days a week, it's a much, much more skeletal network. And I did for an article, I did a set of maps of a number of places, just showing routes that run every 30 minutes to midnight. Obviously in Toronto, everybody's within walking distance of one. In Washington, it gets pretty sparse once you're outside DC. And then even Denver and Portland, it's a fairly skeletal network. And then places like Charlotte and Columbus, very few routes meet even that fairly limited standard. You know, and when you talk about big infrastructure, what is the result of this? How does this kind of local service play into the effectiveness of big infrastructure investments? And you can see in Washington, this is Bethesda Station, which has great transit-oriented development. And it has 18,000 riders a day. This is York Mills. It's surrounded by a golf course, parking lots, big houses on big lots. You would think, obviously, Bethesda would be the much busier station, but that you'd be mistaken, because York Mills is, in fact, the much busier station. Why? Because tens of thousands of people a day come into that station by bus, some from 4, 5, 6, 7, 8 kilometers away. Whereas any station that's reliant primarily on walk-in traffic, a system reliant primarily on walk-in traffic, won't be able to serve the majority of the region's population. You can never build a rail network that's within walking distance of everyone. And so, yeah, you see the big picture. San Francisco, which really focused on park and ride, their system has about 2,000, 2,100 or 2,200 riders per kilometer. Washington, before their big recent declines, have about 5,554. Toronto, 16,800. It really just because it is embedded in a network of frequent transit. And you can see when you look at, as we come to the present day, you look at places, only three US metro areas had ridership growth in 2017. And they weren't the ones that you would think of, Seattle, Phoenix, and Houston. What set them apart? Well, they were the only or they were the most ambitious systems in terms of improving their basic service levels. Now in Phoenix, we're not talking about a bus every 2 minutes, but it was extending that span so the route doesn't stop at 6 p.m. anymore, getting up to hourly or half hourly service all day really made a difference and got people, even in Phoenix, to start using transit. So, you know, the sort of catchy line I like is, when it comes to transit, if you build it, they might come, but if you don't, they definitely won't. You know, so to go back to this, Toronto kind of repeated the American pattern a little bit. It hasn't extended service to the same extent historically to the newer suburbs outside the city of Toronto. And indeed, we saw a fairly precipitous decline, as well as from some service cuts in the 1990s in terms of ridership per capita. And you can see quite clearly here that the area within the city of Toronto has a much higher mode share than it does in the outer suburbs, even in areas like North Scarborough, North York, that have, you know, pretty similar, broadly speaking, land use to parts of the suburbs. You know, and another issue, and this is a Toronto point, but this is applicable to a lot of cities across Canada and across North America. You know, there are a lot of issues around integration. One particular route in Toronto, a comparison, you know, if you're going across a municipal boundary, you pay a double fare. So your fare per kilometer is many times higher for a trip, just because you happen to be crossing a municipal boundary. It's not surprising that fewer people use transit on those cross-boundary routes. As well here, you know, this route would save people 80 minutes if they used this train rather than taking the bus to the subway. But we know from Transportation Tomorrow survey data that only a few dozen people use this faster route, because service is lower and the fare is much higher than take the bus to the subway. You know, so I'll give a bit of a recent success story. And this is Brampton Transit, which achieved a 288% ridership increase from 2004 to 2018, which is pretty spectacular. You know, here's an example that I think illustrates the point, just a quick one. You know, what was it that caused this big increase? I think this route on the weekend, 23 Sandalwood, it's a fairly typical suburban route. On Sundays, they achieved a 177% increase in ridership, because they added 54% more service, basically going from every 47 minutes or something like that to every half hour clock-faced schedule. So, you know, was it because they built more on the route? Well, then you'd see a similar growth on Saturday, where service wasn't improved. Well, on Saturday, you only saw an 18% gain. So it's pretty clear that it was the service improvement that drove this change. And again, when you look at the timing of the improvement, the service improvement happened from 2011 to 2012, and we saw the precipitous increase in ridership from 2011 to 2013. And when service leveled off, the ridership also leveled off. So, you know, what is the point of all of this? The point is that we have to escape the cycle of fatalism that certain areas can't support a decent level of transit service. We need to design a transit service that is universal, that provides universal accessibility for people who don't have cars, so that they can access jobs and other services, just as Stephen was explaining, just as easily as they can, as people can with a car. And so the last part about this is sort of going forward is the data side of this picture. This is something, as Stephen and his team are already working on, that really can be improved with more data, with more analysis, with more geographical analysis, looking at the areas that are lacking in terms of access. The more that we understand this, the more that we understand where service is limited and where people don't have access within a reasonable time to jobs and services, the more we can change policies to make them make them more equitable and make them more economically efficient as well. Because this is, of course, a critical question for all of our region's economies. We can't keep building highways. There's physically isn't the space for it. So if we're going to continue to grow, we need to provide multiple types of mobility options, including transit. So that concludes my talk. So thank you so much. And it's been a real pleasure. And thank you for the invitation.
Jonathan, that was fantastic. Thank you for that presentation. I had no idea Finch West was such a busy stretch. It's profound actually seeing the level of usage that we get. And I'm encouraging folks in the audience to ask questions to Jonathan, because Jonathan, you did a great job of actually comparing and contrasting, the TTC in Toronto to some of the American cities. But I couldn't help thinking about, what about other Canadian cities? I mean, are they on a similar trajectory as Toronto is when it comes to ridership per capita, or are they going towards, some of the way that some of our American cousins to the south are doing? I don't know. I mean, I think that's an interesting question. I would encourage people in the audience to put that into the chat or put that into the QA, and we can start peppering Jonathan with some questions afterwards, right? But we have a few minutes until we get there. So Jonathan, thank you. I'm going to take away your screen now, and please come back in a few minutes as we do our final chat. But just before we get to that final chat, I have a very short few minutes I'd like to spend talking about my crystal ball. Of course, I don't actually have a crystal ball naturally, but I wanted to share some insight and some tidbits or some future predictions, perhaps, let's call it this way. So I have two kids. I have a 10-year-old daughter and a 5-year-old son. And I feel compelled to share this with you because I'm getting to a point where Stephen Farber was poking fun at my multiple vehicles I have in the house. I do not have multiple vehicles in the house. In fact, I drive an old 2005 Acura. And I love driving my old 2005 Acura. It's got a little bit of rust on the bottom. I don't think I can sell it anymore, but I love it. It's an RSX, and it's a 6-speed manual transmission. So that's one of the reason I'm telling you this, is because it's a manual transmission car. And so my children, they sit in the car with me, and they look at me, they say, "Papa," they call me Papa. My daughter primarily asks, "Will I have to learn that? Am I going to have to learn how to drive that thing because it looks messy?" And I said, no, dear, you don't have to learn how to drive this. In fact, it's hard enough now to purchase a vehicle that's manual transmission. By the time you're old enough to drive, you may not even need to drive, perhaps, right? Maybe by then you'd be able to tell the vehicle where you want to go and it'll just do its thing and get there. I mean, she'll be presumably old enough to drive in maybe 6 to 8 years. So we may not be there just yet, but I mean, the concept still rings true, right? It's the idea that even a manual transmission car is becoming rarer these days. So what is the future holding? And so, I did have a couple of things I wanted to share with you in terms of some predictions. And honestly, they're not groundbreaking by any stretch of the imagination. In fact, some of these areas that I want to be talking about are probably common knowledge, but I think it would be worthwhile sharing them. And I wanted to bring back the 3 words that I started off this seminar with. And those 3 words are resilience, collaboration, and access. And we've heard from a number of excellent speakers today of how we need to modernize our transportation systems in these 3 areas. And, I think we heard when it comes to resilience, I believe, and I think Dave Monhan would probably agree with me, that there's going to be a proliferation. In fact, there probably is a proliferation of passive sensors. Dave showed a scene where, you were able to see, it was a demo of the video of, you were able to see the Toronto skyline and all the different sensors that are there. Having an absolute wealth of data and, more importantly, making sense of it allows us to become resilient. And as we move into the future, that's not going to stop. With the advent of 5G and the ability for any one of these cell phone towers to increase in an order of magnitude in terms of the connections that they can uphold or sustain, we have the ability, and combine that with the fact of lower processing requirements, cheaper energy in terms of battery, and devices that can last 10 years without a battery change. All of that brings to fruit that there's going to be sensors in everything, from pavement sensors to seismic sensors to water sensors to traffic sensors to everything. We're going to have tons of these sensors. In fact, we often do already. Collaboration. There's going to be no shortage of people, companies participating in this space. It's going to continue increasing. And I think governments, transportation authorities, Canadian governments need to start taking, grabbing taking the reins again and sitting at the helm and saying, okay, we're working with the private industry to provide these solutions, to be able to deliver these incredible innovations. But we need to lead with that common system of record so that we can collaborate and everyone in this space can play together well, because again, it is a shared system. And of course, access. And, Jonathan's talking about this, and I think a lot of his presentation covered the fact that, we have done fairly well. And when I say we, I'm talking about in Toronto. I live in Toronto, and maybe it remains to be seen as to whether other Canadian cities are doing that. But, we've done pretty good in terms of transit ridership, but we're nowhere near there, right? Particularly in the US. And I believe that even today, cars or single occupancy vehicles, they often tend to direct investment in infrastructure. They still do that. A lot of the models that we use today, travel demand model, are still based on that. Now, we hear about additional models popping up. There's a really interesting one that Stephen Farber, you introduced me to, the LTS, or least traffic stress score, which you can actually measure the ability to put stress on cyclists that help them to determine as to whether or not they're using in a low stress a low stress area to ride on or a high stress area to ride on. And perhaps innovations like these will help us to invest in infrastructure that are not politically driven or driven by cars, and we can actually get better equity across the board. And so there's a small team in Esri Canada, I think many of us believe this, but there's a small team in Esri Canada. And one of the things that we can do is that we started this endeavor about a year and a half ago, where we started to think of what can we provide that's going to help the transportation industry in these areas. And we came up with this idea. Jeff Kirchner, who may or may not be in the audience today, he's behind this drawing. This was the original back of the napkin drawing that our small team put together. And, we devised this idea that perhaps we can create a platform that has the ability to ingest data from all different sources of real-time static information, house it temporally so it's time aware, and deliver that data with value add for things like utilities, construction, emergency response, public safety, routing, whatever you have, so that people can actually make use of this in all areas of transportation. And also, as an added bonus, of course, provide analytics, dashboards, visualizations, planning, and simulation. This is our little team's attempt at creating a system which could potentially be used by Canadian governments to be that authoritative system of record that can be shared for all Canadians to be used. And so we've been working on this, and I just want to share a few insights into stuff that we've been doing. This is definitely a work in progress. But the Transportation Geo Exchange, as we're affectionately calling it, it's designed to help authorities with decision support, routing, transportation modeling, modernization, of course, what we're talking about today. It uses a concept of a 4D or a 3D plus time digital twin. It's an immersive experience. I'm going to show you in a little bit. It's collaborative, open source, so that people in the city, people with consultants, external parties, and even machines, the autonomous vehicles of the future, perhaps even they can access this platform so that they can all have access to a common system of record, which is authoritative, thereby trusted. So we worked on a few different examples, and this was an example of the proliferation of data sensors. If you're in the business of pavement data collection, you know that it's expensive to do that. And so you acquire a third-party company to go out and assess the surface, the condition of your roads, and bring back a report. It's expensive that oftentimes you do it, once a year or maybe even twice a year. Well, with the proliferation of sensors and the cost reduction of these sensors, they can be embedded in any vehicle out there, which is in fact what's happening now. Many of the newer vehicles have sensors built in to be able to detect things like road roughness. So you don't have to send out a consultant to do it anymore. A lot of times it's just passively collected now. It may not be engineering grade because there's too many variances, but it does give a better picture, a living picture of the health of your infrastructure. So we wanted to be able to do a little experiment that showed that. We also ran a little experiment where we could automatically collect information that would help us understand how different modes of travel or different modes of transportation traverse through an intersection. So what you're seeing right now is a manifestation of those traversal paths through just an intersection. This one happens to be in the Netherlands because the partner that we used to create this happens to be a Dutch company. But this was not hand drawn. This was it was created using an analysis of the infrastructure at that intersection to be able to create a map, a multimodal map of intersection traversals. And I think this will go a long way in helping us understand what's happening at an intersection and being able to share that information with people who are doing transit planning, transportation planning, or even the autonomous vehicles that will be approaching this intersection. This is a 3D visualization. Of course, we got to make this thing look neat. So we wanted to make it look really pretty. So this is just a realistic 3D visualization of the transportation geo-exchange. And of course, it includes mode-specific 3D models. So if you look into this, we can actually have an individual on a bicycle, we got a motorcyclist and a person walking. So this truly is multimodal. I mean, I understand there's some visual artifacts here and it's definitely not pretty, i.e. it is a work in progress, but we're using this platform to be able to experiment in this realm. Here's one of the experiments that we did with one of our Dutch partners is using edge-based artificial intelligence on cameras to understand what's happening with vehicles, pedestrians, so vehicles, pedestrians, and cyclists as they move through an intersection. What you're looking at is a 3D representation of all the different modes of transit or transport that are occurring through that corridor. And then we took this 3D visualization and moved it into a dashboard where you can actually see the camera. It's been blurred because there are people in that video. So we wanted to be able to blur it and hide it. But using this kind of information, we can see, actually, you know what? I realized that my video right now is probably covering the pie chart. So underneath my video, there is an image of a pie chart which shows, I'll read it to you because I can see it on my screen. It shows that there is 1,700 cyclists and about 10,000 cars going through this intersection. But this is a dashboard that I'll be happy to share later on, so we can go through it if you wish. But it shows the mode split. And not only the mode split, but the directionality, where these people are going. And all that is happening is there's a partner in the Netherlands called Venotion that's part of this consortium that we're using their technology to be able to display it in this fashion. And then there's another one of our partners, it's called Cyclomedia, also a Dutch company, that's been able to generate, through vehicle mounted equipment, not just 3D visualizations, but also point clouds. And you see that on the right here. This is a LiDAR point cloud that we can use. So you can do all sorts of fancy things. But, you combine all this sort of information together and then put that into an environment which now has the ability to perform simulations. So this is a screenshot of an open source traffic simulation that we use. Now, I need to say this like clearly, Esri is not a simulation company, and there are many simulation engines out there. But our team that's behind the TGX decided we wanted to be able to use an open source style simulation to just, demonstrate the fact that this can be done. So this is the city of Toronto with simulated data in it. And you can see we simulated passenger vehicles, pedestrians, cyclists, trucks, all sorts of different things. And actually, I think I actually had it live open right now, but I had it running in the background a little bit. So it looks like my simulation has stopped. So I do apologize about that. I do start that up again, but this is it. So this is the interactive portion of that simulation, which of course there are no vehicles or pedestrians running around the city of Toronto. So I do apologize about that. But I also had a quick view of some of those other images that you saw. Here's an interactive version of that LiDAR shot. And of course, here's the 3D realistic photography. And of course, the dashboard. And now you can see the fact that there actually is a pie chart there. And I can zoom in and get some more information about what's happening at that particular intersection and be able to see a snapshot of the camera that it saw at that time. So just a very quick view into some of the world that we've been working on here as part of this TGX development. And of course, all of this is being created on a linear reference transportation network so that we can provide a common platform so that all of these different use cases can benefit from. So I guess to wrap it all up, one of the reasons I wanted to show all of these different examples here, those different screenshots, were because I wanted to identify that user experiences should be varied. And what I mean by that is that there are lots of different people who are integrating, or participating is a better word. Lots of different people from different backgrounds and different levels of sophistication that are participating and need to participate in a transportation management system, a system of record. So what happens oftentimes, especially in the realm of smart cities, is you get these solutions that are delivered that might be very excellent. You can get a solution delivered for pavement management, or a solution delivered for transportation analytics, or a solution for road safety, and they may be very good on their own. But what I find is that oftentimes they're delivered in an island. And one of the underlying themes that I believe is important for us to be able to modernize Canada's transportation systems is that rather than creating these beautiful and excellent islands, we can create all of these different user experiences that are fed from a common system of record. And that is really, really important, because then all of these different groups and all these different departments and organizations, the intelligence that is contained within can then span across those. And as a result, we can get better decision-making when it comes to policy reform for transit. We can get better awareness and situational awareness of operations with real-time data. We get an ability to be able to serve up information for the new road users, like autonomous vehicles, or even the delivery drones that are out there delivering burritos. We have this ability to deliver information to them that is immediately useful for their purpose, without actually creating a new island, just for every new innovation that's going to come on the scene, and have it authoritative. So the idea is for government transportation authorities to have their stamp on this, so that they can say that, yes, this is authoritative and you can't trust it. And that enables us to work together with the private industry. So the call I have here is that if this is of interest to you, reach out to folks on our team, reach out to your Esri account manager, and get started with a data assessment to find out how we may be able to help modernize your transportation system if you are a municipality in Canada or a provincial entity in Canada. But that about wraps it up. So we have a little bit of time left to go through some final questions with the group. So let me dive into some of the QA and see what has been asked since I've been talking. All right. While I'm doing this, I encourage everyone in the audience, please go ahead, upvote, ask some questions, because I'm just going to go through the list. All right, so I think the first question here that seems to have the most upvotes would be, back to Dave Monahan, actually. So can or has Velocity or related systems be used as 511 systems?
Yeah, I would say that absolutely. As a matter of fact, it's more like an intricate part of 511. It's what's going on when people call for service through 511, for example, before commuting to work or leaving for a vacation or whatever, and they want to get a status on traffic or what's going on in accidents, that kind of stuff. That's absolutely part of what we can do with Velocity. And in fact, if you take a look at what's out there, if you're a transportation agency, you could have your own sensors that are out there, and certainly Velocity can help report on what's going on there. But the beauty is that there are other sensors that are out there. And if you think about some of the examples that I gave earlier today, tapping into a source like Waze is a very good example of that. That's an alternate source of information, something that people are used to using. But when you start combining that with what the transportation agency has, now you've got new ways of thinking and new ways of looking at the data and providing perhaps more enhanced or more enriched information and therefore services to your customers. So do I think Velocity should be part of 511 systems? Oh, absolutely, right? And I think you'll just see that grow as time goes by.
Excellent. Perfect. Okay, so I got a question here for Lindsay. I'm going to ask you this one because I think it's directed towards you. The question is, can you add your agency's specifications to generate templates? Now, my assumption is that these are specifications that generate templates for ArcGIS Urban.
Yeah, if they're referring to templates in terms of the custom metrics, then you can use data from your own organization. It just requires some some effort on your part, but yeah, it's definitely possible, and it's definitely like a very useful and powerful ability that ArcGIS Urban has.
Okay, so it definitely looks like it's pretty customizable. I was watching David, and it's fortunate he's not here, but I remember watching David make some changes within the system, and I realized that was more of a city engine or complete streets thing, but it looks like there's a lot of ways that cities can really adapt this for their own purposes within their environments.
Yes, yeah, exactly.
Perfect. Stephen, I think this question is for you. Have you noticed a difference in the low activity participation from before the pandemic? And do you think can better equity help offset the effect of large scale events such as the pandemic?
Well, great question. And it kind of speaks to my very last slide, actually, which is that, you know, a lot of the data that we rely on traditionally for these types of analyses is only collected every 5 years. And therefore, a huge thing like a pandemic can happen in the middle of that cycle. And we sometimes don't have access to our traditional data sources in order to assess and answer questions like that. So certainly, there's been a flurry of innovation actually in this space from the pandemic, with most mobile phone companies and Google Maps and Apple Maps as well, kind of creating new sources of data for governments to use to track mobility patterns. And you know, you've seen those bar charts over time of mobility patterns, you know, and participation rates changing over time. And there's been quite a bit of analysis looking at how that compares by kind of geographic unit of where people live. So looking at low income neighborhoods versus wealthy neighborhoods, or neighborhood, you know, and of course we see much more mobility during the lockdown periods in poorer neighborhoods compared to wealthier neighborhoods, where most people had options to continue their jobs from home and pay for more expensive food delivery options and things like that compared to lower income neighborhoods. So lots and lots of amazing evidence coming out from those new types of data sources. And it's a great example. Arav talked about 5G and what we'd be able to do with more ubiquitous sensors and be able to know a lot more about what's happening in real time when we face a crisis in the future. And we can't plan for the next crisis to be a pandemic. I mean, we have to have some kind of general purpose system if we really want improvements, right? If we want to be able to be resilient and have information about whatever it will be, a severe weather event, forest fires, you know, what's going to be the next thing that really impacts our mobility system. We know that it's going to happen, and it's more likely to happen now with climate change and so on, but we don't know what it's going to be. So having these data systems in place, I think, really speaks to preparedness in a lot of ways and resilience. I know there was a second part of your question, but I think I've said enough, and I can't remember what the second part of the question was.
Nor can I, actually. But I was thinking I wanted to ask you a question, Jonathan, because there is one more question here in the chat directly, specifically towards you. And it says, will people return to transit post-pandemic? And I'd perhaps like to add to that based on what Stephen just talked about, right? It's not just pandemic. It could be any sort of scenario, large-scale scenario that occurs. And, you know, maybe you might want to pepper that response with, you know, how we can be a bit more prepared and encourage people to return to transit. Oh, you're on mute.
So to actually, before, you know, I'll answer actually the comment you made at the end of the presentation, which is about other Canadian cities. And I would say, if anything, other Canadian cities have over the last few decades done a more impressive job at some of these things, and certainly across the board, Canadian cities have more transit service and more transit ridership than comparable cities in the United States, for a number of different reasons I won't get into. But in terms of the pandemic, I think it is really, really striking how, how much demand has changed overnight, but how much, how difficult it is to use that to predict 10 years, 15 years out into the future. We're living in a very high flux situation. As people go to work, are locked down again, go to work. And so I think it's really tricky extrapolating too much from this situation. More broadly, I think what it says to us is that more and more trips, and this is whether it's just people working from home from technology because of the pandemic, because of a lot of things, more and more trips are taking place outside the conventional rush hours. And we have a transportation system that has for many, many years, especially on the transit side, been focused on serving rush hour traffic. So making a system that's accessible for anywhere to anywhere, anytime journeys is really, really important. And I think the second point, and this is true of all big cities, is that we simply, we've been hearing, will people return to transit? Where are they going to drive everywhere? It's just not physically possible for everyone to drive everywhere. You can look in Toronto, and this is true of any North American city. The expressways are just about full now. And the downtown office towers are still half or 3/4 or 90% empty. So imagine when we start adding 200,000, 300,000 more workers all coming in at 9 a.m. It's a physical impossibility for these people to all drive. So, and that has not changed because of the pandemic. And even if people aren't all going downtown at the same time, that's still not going to be feasible. So we need in any large, densely populated urban area to have a variety of different transportation options. And that's not going to change.
That's a great response, Jonathan. Yeah, we need a variety. We need to offer people choice. And because without choice, it is an impossibility. We cannot support the amount of people that need to get around the city at the same time, right? So we need to distribute that. But I'm hearing this incredible, dichotomy of, Steve, you're talking about how, the data comes in every 5 years, but yet on the other hand, Dave earlier was saying that we can make use of real-time data, right? So it seems like the ability to collect this information might be there, but do we have the mechanisms to grab that and process it, interpret it, and then turn it around and apply it for things like transit equity? So we can take that information and customize it for our urban spaces. So we can actually start making smarter decisions with the way that we configure our urban spaces and provide access to people to get to, I think your presentation was talking about it, Jonathan, to Yonge and York Mills, for example, right? I think that we're at an incredible time in the transportation industry. One of the reasons I'm excited to be part of this industry is because there's just so much flux. There's just so much innovation. There's just so much change going on. But I keep needing to reminding myself to reel myself back and make sure that I can address some of the comments that my mother-in-law made to me in the beginning of the day, right? Is that, we can't make it more complex. It needs to be simplified. And I think with all of our help together, we're achieving that, or we're getting closer to it. So with that, we are over time. I just want to take a final minute to thank everyone, all the speakers today, David Monahan, Steve Farber, Jonathan English, Lindsay Bedard. Thank you very much. And of course, David Kosowski, who's not able to join us right now, but thank you for taking your time and sharing with this audience your insight into this realm. And I want to be able to thank the audience for participating today, because of course, without you, this wouldn't have happened. So thank you for taking a few hours of your day and joining us in this seminar. If you have any other questions or comments, or you wish to connect with the speakers, please do, right? Let's not have the conversation end. Within the next few minutes, we can definitely continue the conversation. We all have the ability to be reached out to via email, via LinkedIn, by social. Reach out to us. Thank you all, and have yourselves a wonderful day.
Thanks, everyone.
Thank you.
Thank you.